I present to you the top 10 weirdest looking dinosaurs. I want to state the obvious and tell you that I'm going to be butchering the names of these dinosaurs. In at number 8, we have the Tradoon.
In 1856, the fossilized teeth of a small dinosaur were discovered in Montana. The species was aptly named Troodon, which means wounding teeth.
Tradoon.
When evolution passed out the stealth gene, Troodons lucked out.
Tradoon.
This drawer contains almost all of the North American identified specimens of Troodon.
Troodon was every inch the predator, with razor-sharp serrated teeth and large, hook-like claws. Troodon probably fed on our ancestors, the early mammals. Troodon may have posed a greater threat to mammals than any other predator on Earth. The Troodon was suddenly cut down in its prime.
Tradoon.
Well, hello everybody, and welcome back to Paleontologizing. Happy Wednesday. It is, where I live, May 13th, 2026. Whether you're watching live, hello, the chatters, or whether you're watching sometime in the future, maybe in the VOD or on YouTube, I'm glad you're here. Welcome to Paleontologizing. And let me introduce myself to any folks who might happen to be new. My name is Danny Anduza. I'm a dinosaur paleontologist, and believe it or not, this is my full-time gig. This is how I make a living, by doing science outreach full-time. On this channel, well, when we're here in my office in the San Francisco Bay Area, we're usually going over new scientific papers, talking about the history of life on Earth, answering viewer questions, maybe you're interviewing other paleontologists remotely, all that good stuff. But in just a couple weeks here, I'm going to be out in Wyoming digging up some dinosaurs live on stream, like we do every summer around here. My crew is going to be out there in western Wyoming, excavating brand new species of dinosaur, collecting data, all that good stuff, and all under permit, obviously. We work on federal lands. All of the fossils end up at museums. That's the whole point, is we're doing science, you know? And that's what these streams are all about, too. I want this to be your inside peek into how fossil science really works. I've been digging up dinosaurs since 2011, which is, goodness, this makes me feel old. But, yeah, sort of like a solid 15 years. I work on dinosaurs, I publish on them in the scientific literature, and I talk about dinosaurs here on stream. That's where the name paleontologizing comes from. It's like we're taking paleontology, which is normally a noun, making it a verb. I'm trying to show you how it's done, and why it's important, why you should care about it, why your daily life would benefit from a greater understanding of the history of life on Earth, as understood through the fossil record. That's what paleontology is, the study of fossils.
Opie and their 12
Opie tells
raiders
me
would
you're one of
also
these,
like to dig
one of these
deeper.
archaeologists fellas.
Well, he's pretty near the mark. Actually, I'm a paleontologist.
Oh.
We dig deeper.
2Pi, thank you.
In this
For the
program,
follow and for the
all
raid.
those questions
Holy
will be
cow.
answered.
Welcome to Paleontologizing. It's wonderful to have you here. Excellent timing. Welcome, I'm Danny, I'm a paleontologist. Let me play a quick little channel trailer for you to introduce you to what we're all about here on Paleontologizing. BST Mom, how are you doing? Bust Mom? Best Mom. Howdy, howdy, Best Mom. Welcome, welcome. Here's what we're all about here.
My name is Danny Anduza. I'm a dinosaur paleontologist, and this is Paleontologizing.
Oh, and we can talk about that a more of storms if you'd like. Excellent question.
Science isn't just test tubes and beakers and white lab coats. What we're doing out here is science, too. We're testing hypotheses by excavating these fossils.
Join me for museum tours, interviews with other paleontologists, audience Q&A, 3D printing. It's pretty big. Who thought this was a good idea? And of course, live dinosaur digs.
A limb bone from a new duck-billed dinosaur.
I invite you to tune in and experience the adventure of fossil science. Welcome, welcome, everybody. Two Pies says, oh, heck yeah, howdy. Howdy right back at ya. Hope you're having an excellent day. Hope you had an excellent stream. Thank you so much for the raid. A friend turned me towards your channel. Whoever that friend is. They sound pretty cool. Thanks to them. Two Pie, welcome, welcome, and welcome, Raiders. Let me know if you've got any questions. I was just kind of going through a quick little introduction. Like you saw in that video, my name's Danny. I work on dinosaurs. We'll be out in Wyoming digging up dinosaurs again for 2 weeks, starting at the beginning of June. Very excited about that. And holy cow, rabbit or fox? Another raid. Well, well, well.
Fox and their 19 raiders are about to get flattened by dinosaur content.
Welcome, welcome, rabbit or fox and raiders. Basic Crafts.
Really spectacular. Spared no expense.
Thank you for the follow. Urgle Wurgle. Thank you for gifting Wrathcore there. I really appreciate that. It is a raid party, I guess. Holy moly.
Urgle
Rabbit or
gifted a
Fox,
tier
thank you.
1 sub to Rathko. They have given 374 gift subs in the channel.
Rabbit or Fox says
These
raid
are just
party.
some of the questions that people ask about dinosaurs.
I really appreciate the raid. Welcome, everybody. Fantastic. Yeah. You were doing some makers and crafting? Very cool. We do a lot of that here too. All of the fossils that you see in the backdrop of any given stream, I change these out every day. These are all 3D prints. Here's a 3D print of a particularly common dinosaur that you might find today in major world cities or suburbs or exurbs. These guys are very widespread. One of the most widespread of living dinosaurs is a 3D print. We do a lot of 3D printing on this channel, and occasionally some sculpting, digital sculpting, and it's been a while since I've done 2D art, but I do a good deal of that as well for my science if I'm illustrating papers and stuff like that for publication. Anyhow, yeah. Colorwork sweaters. Very cool, Rabbit or Fox. Yeah. Maybe we'll do some more 3D printing today. I have... Here, I'll show you what we've got on the printer right now. Here. Here we go. And Lana Jane, thank you for the follow too. Welcome, welcome. It's good to have you here. Check it out. This is a really, really simple, quick print. I plan on using these for a few things. I'm out there in Florida next week. I'll be out digging dinosaurs in Wyoming at the beginning of June, but prior to that, I'm going to Florida to go see these guys. Who can tell me what this critter is? Maybe to help you out. I'll show you.
Tradoon.
What is this creature? Yeah. Does anybody know the genus and species name? This is Dermachelys coriacea. The mighty leatherback turtle. Largest turtle in the world, one of the world's largest living reptiles. These creatures have been around since the time of the dinosaurs. They were swimming around in Earth's oceans. At least the ancestors of these guys, members of Dermachelidae, this family. There's one surviving species today, Dermachelys coriacea, and they really need our help. I'll be talking all about these guys on Friday, and we'll even be doing a special interview with a leatherback turtle researcher. You'll tune in for that. But this is why I'm going to Florida next week, to see these critters and a bunch of other stuff that Florida has a natural history wise. Yeah, Tupai says, I never knew turtles could get that big. They're pretty extraordinary animals. They really are. Yeah. Here's another crew that I'm hoping to work with in September. There's Scott Benson there on the turtle's left, our right. I interviewed Scott Benson in Monterey, California back in December. With any luck, fingers crossed, I will be on this research vessel, the same exact boat, in September, doing some field work here, right off the coast of San Francisco, near where I live, in the beautiful, sunny Bay Area. Yeah. But anyway, for now, I'm going to Florida next week, where we'll see leatherbacks in the Atlantic Ocean. Anywho, yeah. Family Dermachelidae, exactly. Amor of Storms, yes indeed. Yeah. And for anybody who just came in with Rabbit or Fox, let me play a quick welcome video for you too. We just got done playing this for Tupai and their raiders. It's less than a minute. Let's play it again real quick. There we go.
My name is Danny Anduza. I'm a dinosaur paleontologist, and this is Paleontologizing. Science isn't just test tubes and beakers and white lab coats. What we're doing out here is science, too. We're testing hypotheses by excavating these fossils.
British Columbia for museum tours, interviews with other paleontologists, audience Q&A, 3D printing. It's pretty big. Who thought this was a good idea? And of course, live dinosaur digs.
A limb bone from a new duck-billed dinosaur.
I invite you to tune in and experience the adventure of fossil science. Yeah. So I'm primarily focused on fossils, but there's a few modern creatures that have really captured my imagination. The leatherback turtle is first and foremost among these, and we're going to be having some more leatherback turtle streams and trying to raise awareness about these animals, trying to get people excited about their conservation, so they can make it into they can survive for the next 80 million years, you know? Anywho. And Boogie's Bungalow says, are you going to stream your work with leatherbacks? I'm hoping that we'll be able to visit a leatherback turtle not hatchery facility, but a laboratory where we've got baby leatherbacks. Fingers crossed we'll be able to stream from there. I actually need to send an email out about that ASAP. But I will be doing at night, like in the dark, on the beach field work with nesting mother leatherbacks in Florida. I don't think we'll be able to stream that, but we'll see. That's the thing. This is an endangered species. There's a lot of these are protected animals. Even photographing them can sometimes be a little bit squirrely. I want to make sure I'm absolutely playing by the rules, and you know what I mean. But with that said, I'll have to see what conditions look like on the ground there. I do happen to have a pair of night vision binoculars. Well, I don't have a night vision camera. We could set up the night vision binoculars on a tripod and then put the camera at the back of it pointing to the monitor, and we could try and jury rig a stream like that. But again, I want to emphasize this, no promises. And these streams would be in the middle of the night anyway. Like, we're talking midnight or later, when I'm normally asleep, and most of you probably are too. Midnight Florida time, which is 3 hours ahead of my time zone here. So we'll see. But, yeah, not me, I'm ready, says Claire. Well, yeah, keep an eye on your notifications, Claire. Maybe, who knows? Who knows? But again, no promises. And we will be doing a special stream. If you want to hear more about this leatherback turtle fieldwork before it happens, then I'd recommend you tune in to Friday's stream. Because we're going to be having a special bonus Friday stream with Dr. Justin Peralt of the Loggerhead Marine Life Center. And we'll be talking a little bit about this fieldwork before I go there. And yeah, bring your questions. It's going to be really good. Anyhow. Anyhow, it's good to have everybody here. And shoot, for today's broadcast, I'm sure we'll be talking about leatherback turtles at least a little bit. But we're going to be focusing on some fossil news. I've got a few hand-selected, hand-picked new paleontology papers, many of which Dr. Terminator actually brought to us in chat yesterday. We've got some exciting new dinosaur discoveries to go over today, and I'm looking forward to helping translate those for you. You know, scientific papers can have a good deal of jargon in them. I'm going to do my utmost to make them understandable and tell you about why they're important. I'm excited about some of these because they kind of deal with key research questions that I have about dinosaurs. How much individual variation did dinosaurs have? And what bearing does that have on whether two specimens are the same species or different? That's really important. We'll talk about that today. We've got a new paper on Pinacosaurus, which is a big armored dinosaur, like this Euplocephalus here. Euplocephalus is from Canada. Pinacosaurus is from Mongolia. But they're related. We'll be talking about them today. And then also, they're one of my favorite groups of dinosaurs, the Alvarezsaurs, like little Trirarchuncus here. This is a sculpt that I did of Trirarchuncus, and then I 3D printed it. But this is a dinosaur that's very near and dear to my heart because it's one of my dinosaurs, in the sense that I'm one of the authors on the original paper describing this critter back in 2020. These guys are incredibly weird and cool. They're small, probably insect-eating dinosaurs. They've got these short, stubby arms that are extremely robust, and there's one big claw on each hand that they probably used for, say, digging into mammal burrows, maybe prying apart rotting logs to get to the bugs inside. These guys ate small critters, a lot of arthropods, insects, and maybe our ancestors too. They may have eaten mammals. There's a new paper looking at those forelimbs and talking about how they may have been used for digging. So we'll talk about that today too. But and a more of storms. Let me get to your question right now. Thank you for asking it. Let's talk about dinosaur coloration for a second. And here to help illustrate this, let me grab a 3D model that I've printed and assembled, but I haven't painted yet. But it has to do with your question. I hope you're still here. This is a very special critter. This is a little dinosaur from China called Sinosauropteryx, whose name means the Chinese lizard wing, Sinosauropteryx. Sinosauropteryx prima, the first Chinese lizard wing. And I haven't painted this yet because it would take a lot of effort to do that. I would have to be careful about it because this is a dinosaur that you can't really use a lot of guesswork with in coloring it in. If you want to paint this critter, you got to do it right because we actually know what colors it was. And you might be asking, what? What are you talking about? We know what colors it was. It's a dinosaur. This critter died like 120 million years ago. How in the world do we know what colors it was? No, it's not guesswork. It's not wishful thinking. Fossils of this critter are so incredibly well preserved that they have soft tissue incorporated in. So you see that fringe that runs along the animal's back and up its tail? Those are feathers. This is the first unequivocal feathered dinosaur ever discovered. Feathered non-avian Mesozoic dinosaur ever discovered. And those feathers are so well preserved that we can actually tell what colors the critter was. There are melanosomes, which are tiny little organelles within the cells of the feathers. They show us that this animal was primarily orange and had white stripes running up the tail like that. Incredibly cool. Incredibly cool. And Tiny Rebel, thank you for the follow. Thanks for dropping in. Good stuff. And here, I'll just so you know, I'm not making this up. What color were dinosaurs? Excellent video from SciShow here. I think Brother Hank hosts this one.
We know a lot about dinosaurs, like how big they were, what they ate, even how quickly they moved. But there is one question that has plagued paleontologists for decades. What color were dinosaurs?
Yep.
It might sound superficial, but trust me, it is not, because until we understand their coloration, we'll never be able to fully imagine dinosaurs. We won't know what they really looked like, of course, but we also won't be able to study things like camouflage or display behavior, and we will never know the full extent of just how wrong the Jurassic Park movies are. Thankfully, in recent years, a more complete picture of dinosaurs has come into focus, and it is in Technicolor. When you picture a dinosaur, the colors that come to mind probably vary depending on how old you are. For much of the 20th century, for instance, dinosaurs were always depicted in drab colors, gray, green, and brown. That's because back then, most experts thought that dinosaurs behaved like overgrown lizards, so they probably looked like that too.
And we'll here, go a little bit deeper with this tangent here. Give me a second, and let's see. Is this what we're looking for?
To see another day.
Yeah.
Much of what we know about Diplodocus is a result of America.
No, hang on. That's not what we're looking for. Hang on. Give me just a second here. Bingo.
This is Yale University's Peabody Museum, where John Ostrom is curator.
I want you to get the full effect of this, like, revolution in dinosaurian thought. And this is a nice place to kind of bring this to for the moment.
I'd like to introduce you to the largest painting in the world. It portrays time over a span of about 350 million years, from the Devonian period back in the Paleozoic all the way up to the end of the dinosaur era, the end of the Mesozoic. It's called the Age of Reptiles.
Reptiles. Be pretty drab colored, right? And this is beautiful artwork for the time, for 1947.
Here is the old picture of dinosaurs. Pea-brained giants lumbering through lush tropical foliage, gorging themselves on leaves and grass. For years, the stereotype was magnificently represented by this mural.
Since the 40s, when it was painted, a number of discoveries have been made, and new ideas have been thrown into the debate. And perhaps one of the most important discoveries
I love this.
Was made by me.
John Ostrom was very proud of this. I mean, and rightfully so. He helped change our picture of dinosaurs.
1964. John Ostrom recalls that he had been digging for months in Low County, Montana, and not finding very much. Time had run out. His crew had packed up their equipment and were heading for their cars.
You know, we've been looking for 5 years before we found anything as exciting as this.
Close to where the cars were parked, Ostrom noticed something in the rock. Since his tools were already stowed away, he began to scrape the dirt with his fingernails.
Rathcore, you got it.
He saw first.
Yeah, Deinonychus.
Startling. I couldn't believe what I was looking at. Notice the extraordinarily large claws, sharp, curved, clearly the hands of a predaceous animal.
Yep.
Associated, found very close to this, was this object, obviously a claw, which I thought belonged to the hand because it looks very much like the claws on those fingers. But there was no place for it to fit.
Yeah, all the fingers are accounted for, all the
claws
claws
over
are
that for some time, but we found the answer.
It doesn't belong to the hand.
Turns out that that claw didn't belong to the hand at all. In fact, it belonged to the foot.
Mm-hmm. That's the famous killer
Then
claw.
something more came to light in our quarry, and I'll show you just a part of it. Bits and pieces of the tail, encased in bundles of ossified tendons all along each right side, left side, underneath this.
So ossified tendons are tendons that start off as soft tissue in the animal's early life, and over time those tendons turn to bone. So they actually ossify. They harden into bone as the animal grows and matures. Why in the world would you have that on your tail?
Made the tail completely stiff, like what I picture as a balancing pole. It kept the animal, helped the animal keep its balance
so lucky for
while it was using those sickles on its feet for killing whatever it was hungry for.
Yep.
Ostrom named the animal Deinonychus, terrible claw, a killing machine that came into being more than 100 million years ago and used both hands and feet to snatch and rend its prey, keeping its balance by the remarkable adaptation in its tail. Nothing like the galumphing brutes in the Yale mural. But a speedy acrobat, a racer.
So Deinonychus helps change the way that we think about dinosaurs, you know? And John Ostrom is immensely proud of this. So Deinonychus not only helped us understand that, shoot, a lot of dinosaurs were fast-moving, probably intelligent, possibly warm-blooded, just sophisticated, dynamic animals. We realized that they had full-color vision, just like birds and crocodiles. So Deinonychus helped us realize that a lot of dinosaurs were probably warm-blooded, which is a big surprise, because everybody was used to thinking of them as being reptiles, and they thought, well, like modern reptiles, they must be cold-blooded, you know, generally pretty chill, fairly sluggish animals, maybe not the brightest, that kind of thing. These are stereotypes about ectotherms, cold-blooded animals. Deinonychus helped us realize, oh shoot, a lot of dinosaurs weren't like that. And what's more, Deinonychus is extraordinarily bird-like, so it helped us realize that it's very closely related to birds. Birds evolved from a dinosaur much like Deinonychus. Birds are dinosaurs. Dinosaurs aren't even extinct. We have thousands of species of them today. How many species?
Over 9,000!
There are literally over probably 10,000 species of birds on our planet today. The dinosaurs never did go extinct. Not completely. Anyway, that feeds back into what we're talking about here. John Ostrom thought that Deinonychus should probably have feathers, and one of his students, Bob Bacher, actually, oh, hang on. Wombat Hole. Thank you for the 100 bits. Yeah.
Colors.
It's true, Wombat Hole. Yeah, so birds can actually see more colors than we can, and so birds that appear totally black to us, like, say, blackbirds or, to a certain extent, starlings or ravens or crows, there's iridescence in those feathers. Those are colors that we can't even imagine because our brains don't work that way. Our eyes can't perceive that, but birds can see colors in there, which is really cool. Anywho, one of Ostrom's students, the guy who discovered Deinonychus, he had a student named Bob Bacher. And back in the 80s, Bacher was really kind of pushing for a lot of Ostrom's ideas and helping flesh them out. And in this book from 1986, Bacher has some illustrations of Deinonychus, and he makes kind of a bold assertion here. He says Deinonychus probably had feathers. Here's his depiction of Deinonychus, not a slow-moving, galumphing brute, but an extraordinarily active bird-like animal. And I love the feathers flying there. It's just lovely. Again, this is from the 80s that Bacher did these illustrations. There were paleontologists like Bacher and Ostrom who were speculating that dinosaurs like Deinonychus probably had feathers, but we didn't actually have proof. Until this.
To your hair. Each melanosome contains some type of melanin, which is a natural pigment. And based on their density and distribution, they can create different colors. Now I know what you're wondering. What in the name of Charles R. Knight does a Jurassic squid have to do with dinosaurs? Well, you know what else has melanosomes? Feathers. Experts can look at the feather of a living bird, like a cardinal or a crow, and see what kind of melanosomes make that feather's color. For example, long, skinny melanosomes make black and gray, like the black you find around a cardinal's eyes. But if melanosomes are short and round, they make reddish colors, like what you would see on red-tailed hawks. This information can be used as a template for studying ancient animals. So living dinosaurs are basically the color key to extinct dinosaurs. In 2010, this idea was put to the test in a place that's famous for its abundant fossils of feathered dinosaurs, China.
Yeah, so it wasn't until about 1996 that feathered dinosaurs found in China were kind of made known to the public at large. People had been finding fossils of feathered dinosaurs probably for several years before that, but paleontologists realized what they had and they went, holy cow, this is a really, really big deal. Let me see if I can find you the clip of that with friend of the stream Matt Lamana. There we go.
Place. Dug up something interesting in a rural area of Liaoning province in northeastern China. He had found similar fossils here before, but this one was by far the most complete.
What?
Li could only guess what it was, so he bought a train ticket to Beijing and took one of the slabs to Dr. Ji Chang of the Chinese Academy of Geological Sciences.
The specimen I got is not the first specimen. That's the third specimen. In 1995, the first specimen was found, but the local farmer gave it to Nanjing Institute of Geology and Paleontology. They thought it's only a small theropod, that's all.
As he studied the fossil,
What is that?
He observed a curious feature.
What?
An odd, feather-like fuzz, what we now call proto-feathers, on its body. All birds have feathers, but the animal G was staring at was clearly no bird. So he named it Sinosauropteryx, meaning Chinese lizard wing.
Yep.
It was the first feathered non-avian dinosaur ever discovered in China.
That's this dinosaur here,
and indeed,
which I haven't painted
anywhere in the world. Only the world didn't know it yet. That would take another year, when another scientist from the Nanjing Institute, Dr. Chen Peizhi, attended the 56th annual meeting of the Society of Vertebrate Paleontology.
Yeah, SVP.
If he'd attended the Society of Vertebrate Paleontology meeting that took place in Laramie, Wyoming, or in Bozeman, Montana, or in Norman, Oklahoma, it might not have had the same impact. But the 1996 meeting was held at the American Museum of Natural History in New York. So Chen Peizhi brought photographs of a small Chinese dinosaur with a fringe or frill of feather-like structures running down its back. And he just didn't bring the fossil, just brought photographs. He didn't give a paper, he just walked around showing scientists these photos, and the effect was electrifying.
And so, I think it might have been Matt Lamana who told me this story. John Ostrom, at the time, who discovered Deinonychus, John Ostrom was pretty old at this point. I think he died around 2005 or so. But he was there at this meeting. And he took a look at these photos. And he had tears of joy in his eyes. He said, I've been saying this for decades, that dinosaurs had feathers. And here you've gone and found direct evidence. And you have proof now. I think that's beautiful. You know, like, I love this story. It was proof that, well, shoot, in a way that birds evolved from dinosaurs. If dinosaurs had feathers, and no other creature on the planet has feathers except birds, that kind of tells you where birds came from, you know? Pretty extraordinary.
Soon, Sinosauropteryx was making headlines. Over the next several years, Liaoning proved to be a treasure trove as more astounding discoveries were unearthed. Among them were Caudipteryx and Protarchaeopteryx, and Microraptor guii, a weird-looking creature with long feathers on both its arms and its legs. The Liaoning discoveries conclusively demonstrate that feathers occurred on many types of ancient animals, some of which were clearly incapable of flight.
They're all dinosaurs.
They also raise a compelling question. If some feathered dinosaurs couldn't fly, how and why did they evolve feathers in the first place?
Ooh, great question. Anyway, that Sinosauropteryx there, we'll get back to that here.
There, a team of Chinese and British scientists studied what might be one of the most adorable dinosaurs ever, the chicken-sized Sinosauropteryx.
Yep.
Sinosauropteryx was the first non-avian dinosaur to be discovered with structures of feather-like fluff back in 1996. And after studying the melanosomes found in that fuzz, researchers determined that Sinosauropteryx was ginger. Its downy coat was apparently reddish-brown over most of its body, but its tail was a little different, alternating between light and dark bands, giving it some extra flair. Vinther and his colleagues used this same technique to reconstruct the plumage of another feathery pigeon-sized dinosaur called Anchiornis. And it turns out that this dinosaur looked kind of like punk rock magpie, mostly black and white on its wings and legs with a splash of red on its top. After this, the colors of more dinosaurs were soon revealed. The four-winged Microraptor, it had dark iridescent plumage, kind of like a raven, and one specimen of the little horned dinosaur Psittacosaurus was even found to have melanosomes in its skin, revealing that the dino was dark on top and light underneath. Pretty cool, right? As long as the dinosaur is preserved with feathers or some other structure that keeps melanosomes intact, scientists can figure out their basic colors.
So that's what you need, is you need some kind of integument like that that's preserved. You need to be able to find melanosomes in it, look at them under the microscope, determine their shape. Different shapes correspond to different colors. And there you go. You can use modern creatures like birds as kind of your key there. You look at the shapes of their melanosomes and what colors those correspond to, and that's your key. That's your Rosetta Stone, so to speak. We've been able to do this for a number of different dinosaurs and other critters at this point. Not too many, but a few. Again, because it requires very specific circumstances of preservation. But no longer is the coloration of dinosaurs purely the subject of speculation. Nowadays, we can actually start to figure this out with science. So there's a small handful of dinosaurs where we actually know their coloration. Loosely. We don't know every square inch of them, but it was a good picture of what they would have looked like in life, which is incredibly cool. Because when I was a kid, the saying was always, we'll never know what color dinosaurs were. A bunch of kids' books said this. We'll never know. Never, ever, ever. So don't even worry about it. Just empty out the whole box of crayons and just go nuts. Don't worry about it. Well, now we don't have to worry about it, but we can figure it out. And that is something that's happened within my lifetime. I think that's incredibly cool. Yeah. And Cert says it's so amazing that microscopic structures like melanin fossilizes. Yeah. Oftentimes you need exquisite preservation to get that, so it's not common, but it's not unheard of, Pretty neat. Anywho. And Cert, did you mention earlier you were talking about the narrator there?
After all, who needs feathers?
And feathers develop in a very unique way. Initially, a lot of people thought that having scales are...
Let me go back a little bit.
Conclusively demonstrate that feathers occurred on many types of...
That narrator is Matt LaManna, who's a friend of the channel, and hopefully I'll have him on camera in Wyoming again this year. Because he sometimes joins our crew out there. And, there we go.
Allosaurus.
No, we don't have that yet, but we've started to find that. What we call anagenetic lineages, so...
There we go. Here's Matt LaManna.
The lost dinosaurs of Egypt. I think it was about...
Here we go.
Dinosaurs and all kinds of cool...
Museum.
Pertaining to dinosaurs, pertaining to museum work, pertaining to... I don't know, what else are you eager to talk about?
I would say, in particular, my knowledge base is mostly Southern Hemisphere dinosaurs and sort of, dinosaur museums, I guess. So,
nice. Yeah, and again, just for context for anybody who maybe wasn't able to catch any of our earlier streams, Matt LaManna has done a ton of field work all over the world, digging up different dinosaurs in all kinds of cool exotic places. Exotic sounds like almost condescending or something like that. But...
I think some are pretty exotic, so
yeah. And shoot, I've told you this already, but when I was a kid, there is this TV show that my dad taped for me called The Lost Dinosaurs of Egypt. I think I was about 10 years old, and I thought this was the coolest thing in the world. This group of paleontologists go out to Egypt to try and sort of rediscover some of these mysterious Egyptian dinosaurs, many of which, I think pretty much all of which at that point, had been destroyed in World War II.
100%.
And Matt LaManna was on that crew, and so I watched that tape so many times I practically wore it out. And now, get to have Matt out here in the field with us, and now you're on my show, which is crazy.
And you've been a lifesaver to me and my people as well from Pittsburgh.
Shoot,
so,
I appreciate that. No,
this dude is one of the best field people I've ever worked with. No joke. Yep. And
wow.
He's not paying me to say that. And this is only my second beer, so.
No. Goodness. Here's a link to that VOD there. We'll be back out there in Wyoming, beginning of June. I cannot wait. I'm a little jealous, just a little bit jealous of my crewmates who are leaving on Friday to go out there to the field. Normally I'm there right at the beginning of the season, but they're starting 2 weeks early this year. And Lordy and I had already booked this trip to go out to Florida to work with leatherback turtles, and so missing the beginning of the field season for the first time in years. But that's okay. We'll be out there beginning of June. It's gonna be good. Yeah. And Chased by Sea Monsters, I agree, Rathcore. We've watched clips of that many times here on this channel. It's a lovely intro to lots of marine organisms from before the present. I'll put it that way. That's a lot of fun. Rathcore, there's a lot of overlap there between you and me, for sure. Glad you're here. Buggo Wuggo says, I don't think I'm used to Matt having hair. What do you mean? Matt LaManna has hair. What are you talking about? And Murph says, full 45 days in Wyoming? A lot of digging to get done in that time. Absolutely, Murph. I was just talking with Ethan this morning. I'll be out there for 2 weeks, it looks like. Shortened field season this year. Ios and Lordy missed me a lot last year. I was out there for 33 days, whatever it was. So I'll be out there for hopefully a very impactful 2 weeks. But if anyone wants to help support our fieldwork efforts out there, there we go. We've got a wish list with different items that we could really use out there, from oyster knives for digging to sunscreen, paper disposable biodegradable bowls, clay needle tools for clearing away the matrix from some of these fossils, storage bags, things like that. Maybe not the most exciting stuff, although holy cow, we could use a lot more of these. What I used to call plaster grenades. The little medical bandage things for wrapping small fossils in the field. Anyway, very proud of this community for already purchasing a bunch of different items off of here. Ethan's like, we're doing really well. But there's still a few items on there, and this is the last day to purchase them before they leave for the field. It'll be on Friday the 15th. So, Patrick Pirate, holy cow, thank you for the 57 months of support there. Patch, thank you.
What is he up?
Yeah. I appreciate that, Patrick Pirate. Thank you for the prime. And you're going 1st of June to Wyoming? I'm not sure about the exact timing yet, Murph. Because I'll just be getting back from Florida on the 28th, I think. And then it usually takes me a couple of days to drive out there to Wyoming. So I might be either the 2nd or the 3rd or something. Or maybe it will be the 1st. How many days do we have in May? Is it 30 or 31? I never learned the song in school. 2026. 31 days in May. Okay. So if I get back on the 28th, I might be there on the 1st or the 2nd. We'll see. Yeah. We'll see. Getting close to a whole year now? I think so, Patch. Eddie. Freelancer says you use your knuckles to see how many days are in a month. Freelancer, I'm a lover, not a fighter, I don't want to have to beat anybody up just to be able to tell how many days are in a month. Anyhow, let's take a quick screenshot for Blue Sky here. Post that we're live. Let's see if that screenshot is usable. And ever found an Albertosaurus? I have not. A More of Storms. No, I've worked with Gorgosaurus and Daspletosaurus, probably, but never Albertosaurus. I've done a lot of work in the Judith River Formation. Denver Fowler and Liz Friedman Fowler in Montana years ago. But that's usable. We'll go with that. Albertosaurus might have only been found in Canada so far, and I've never done any fieldwork in Canada, not yet. Let's post this. hopefully someday, inshallah, be able to make it out there to Alberta, find some Albertosaurs. Yeah. And you're in British Columbia. You know, you have leatherback turtles up there. Both on the Pacific and the Atlantic coast of Canada, you get leatherback turtles. A lot of people are surprised to hear this, but the Canadian Sea Turtle Network is an organization that monitors leatherbacks, helps train fishers to disentangle leatherbacks that get caught in fishing gear, all kinds of stuff like that. So I don't know how close you are to the coast there in BC, but the Canadian Sea Turtle Network, they do really good work. They're on the East Coast. Check this out.
Alcide Arsenault has been fishing for 70 years, but he's never had a day like this. He discovered an endangered leatherback turtle in his lobster traps. He called the Department of Fisheries and Oceans.
So they said, okay, now you're going to lose your trap or lose a turtle. But I said, we don't want to lose a turtle, that's for sure.
Good for him.
Fisheries officers rushed to his boat off Cape Egmont. The turtle, more than 5 feet long and weighing over 1,000 pounds, was stuck. They managed to cut her free.
Look at that, she went, take off. As soon as they got her loose, it didn't take her long to get down. I said, was the turtle in good condition? Was it lively? No problem. The turtle, it didn't hurt her at all. So then I smiled. A smile came up my face because, you know, it's something like that you want to protect.
DFO says turtles often die when they get caught in fishing gear. In fact, 2 endangered turtles have been found dead in the waters around PEI this month. And DFO's Kent McRae says that is what makes this a rare happy ending.
For us to get the call from the fishermen, for them to have the survival of the turtle ahead of the recovery of their equipment, this was, everything went well. Everything went just as you'd hope.
Yep. And so for this guy, I mean, he said, you know, we could either save the lobster trap or save the turtle. And he says, I want to save the turtle. I hope everybody, like, in this community saw this news report. They heard about this, because I don't think this guy will ever have to pay for another beer in his life. Like, people are going to be buying drinks for him at the bar every time he goes for as long as he lives. Something that's probably more than paid for itself. Who cares about a stupid lobster trap, you know? This guy values what's important, and good on him.
For Arsenault, well, he's back to fishing. The promise of another day for him and for the freed leatherback.
And the turtle, I hope she's happy wherever she is.
Patrick Fowler, CBC News, Cape Egmont.
Good stuff. Here's a link to that video there. Love his accent too. Yeah, the heavy, like, Irish influence in his accent, it sounds like there. And Amor of Storms is kind of hard not to get into paleontology when you get into geology. Agreed. Yeah. Here, I want to show you a book that I got for this upcoming trip to Florida. And I promise you, it's not a joke, okay? Ready? Roadside Geology of Florida. I'm really impressed with this so far. The Roadside Geology of different U.S. states series is really cool. I've got a bunch of these. Just about any time I spend any significant length of time in any state, I'll get, California, Northern California, Southern California, Utah, both Michigan, Nevada, Idaho, Wyoming, Colorado, Arizona, Montana, and now Florida. Florida's geology is not always the most accessible. Florida's not really the sort of place that you think of when you're thinking of geology and maybe fossils. You know, to a paleontologist like me, when I'm used to thinking about fossils and the places where you find fossils, I'm picturing territory like this. Like up in Alberta, or Montana, or Wyoming, or Utah, or New Mexico, or Colorado to a certain extent. That's where you find these badlands like this. Not so in Florida. But there is very interesting geology in Florida, and it definitely makes the state what it is. This book, you were talking about how you can't get into geology without also getting into paleontology. This book, I think, helps illustrate that because so much of it is on the fossils found in Florida. And this makes this easily one of my favorite roadside geology books because there's such a heavy focus on the fossils. And there are a lot of tremendous fossils from Florida. And we'll be talking about that on Friday, and if I do a stream on Monday, we'll talk about it on Monday too. Before I head out there. Good stuff. Yeah. And Charlie's Dragon says, geology in Florida? What? Isn't most of it just swamp? I mean, a lot of the fossils are found underwater in that state, for sure. Here's a good example of that here. Hugga Wugga says, I figured the soil would be so acidic that fossils disintegrate. Not so.
With an incredible fossil discovery. They uncovered the jaw of a mastodon along with a pair of tusks dating back to the Florida Ice Age, more than 10,000 years ago. As Fox 13's Jordan Bowen reports, they found them while diving in local waters and think there could be more down there.
You can hear the screams of excitement through their scuba masks. They couldn't believe their eyes. They had just uncovered one of their best finds yet.
All of a sudden, we're just kind of swimming around, and I wave my hand like this, and the silt reveals just the two teeth, completely whole, sitting right there in front of us.
Amazing. The jaw of a mastodon, and not far away, two tusks. Fossils at least 10,000 years old.
I heard screaming, I heard hooting and hollering. I look over to the side, and there's Rick with these two massive teeth.
Henry Sadler and Rick Cochran are both teachers at Admiral Farragut Academy and frequent dive partners on the weekends.
These tusks, unfortunately, are really fragile. You can see where they're peeling apart away right
They made the discovery while diving in local waters on private property.
The
mastodon animal is similar to that of a woolly mammoth. As Cochran explains, finding tusks like these in such great condition is nearly unheard of.
Sometimes you can have things that literally will turn to dust right before your eyes, and things that can be very hard. This was somewhere in the middle, so we got really lucky with it. Even the tusks, ivory doesn't fossilize well. The ivory tusks you see from woolly mammoths and stuff, they tend to come from Siberia or the permafrost, not so much our Florida rivers. And so when we find them, they're very fragile, very hard to get out.
It's why they used zip ties to help keep them intact. The tusks are now being stabilized, which means they're using chemicals to make sure they'll be preserved for years to come.
So yeah, they're going to hit those
We'll
with
need to wait a few more weeks for them to fully dry out.
some consolidant glues, so some like PVA, polyvinyl acetate glue, the sort of thing that we use in the lab. Hopefully that's what they're using.
Out before they can begin the stabilization process.
We really pride ourselves on giving the kids opportunities that they wouldn't find anywhere else.
Once the fossils are stabilized, Sadler and Cochran plan to display them in the classroom, giving students an up-close look at history, dating back more than 10,000 years.
We use that as a hook to kind of bring them into science and talk about other things around fossils.
Sadler
And that's what I do too. Here's a link to that video. It's got like a couple seconds left. That is one of the beautiful things about paleontology, about fossil science, maybe dinosaurs in particular, is that people in the general public are fascinated by dinosaurs, as they well should be. And we as scientists can use that as an opportunity to talk about broader things, the history of life on Earth, evolution and extinction, and the origins of biodiversity, and learning from the past so that we can live a better future. Maybe maybe avoid the causes of extinction that creatures in the past have succumbed to. It's important stuff, so that's kind of what we're all about here.
Once we knew only that they vanished. Now we know the dinosaurs ruled the land longer than any
Dyson
creature before
Dinosaur
them
and their
or
20
since.
raiders want to know more than that.
Dyson Dinosaur, how are you doing, Filippo? Welcome, welcome. I hope you had an excellent stream. That right there, Filippo Bertozzo is Twitch's other resident dinosaur paleontologist. Filippo, I hope your stream was a really good one. It's wonderful to see things are good. Celtrio Venator says hello. Hello to you too, Celtrio Venator. Sounds like you're in the right place. Welcome, welcome. Celtrio Venator, is that a... What kind of theropod is that? I forget. Is it an Alvarezsaur, or is it like a Neovenatorid? Celtrio Venator. Is it from Italy? Where's it from? Or is it from Argentina? No, it's a Ceratosaur. Early Jurassic of Italy. There we go. Yeah. Knows what I know. Goodness. Welcome, welcome, Celtrio Venator. It's the big Ceratosaur from Italy. Nice. Yeah. Early Jurassic, too. That's got to be really phylogenetically important. You know? Very cool. Anywho, Filippo, I hope you had an excellent stream. It's good to have you here as always. For anybody who might happen to be new, here's a quick little welcome video. Introduce you to the channel. And we're going to be covering some exciting fossil news today. So I'm glad you're here.
My name is Danny Anduza. I'm a...
Hang on.
Urgle just nourished the locals with 20 subscriptions.
Urgle, thank you for those 20 gift subs there. Holy moly, Urgle. Thank you. And I see some familiar names there in the recipients list. Rainstorm Fur, Pilgrimage, excellent. Thank you for your support, Urgle. That means a lot to me. It really does. Thank you. Holy cow. 20 lucky chatters won't have to watch a single ad for the next month. And Celtrio Venator, thank you for the follow. Welcome. Appreciate it. We were just commenting on an incredible product of paleo art from Italy. Oh, very cool. Veil Haiku and Adrenas, how are you doing? Welcome. And Clovet Art says, I have to say, science communicators like you have inspired me to go back to school. Pursuing higher education as an older adult is nerve-wracking, but I have entrance exams coming up in 2 weeks for university biology program. Holy moly! That is really exciting, Clovet Art. I wish you the very best of luck. That is awesome. And you know what? It's probably going to be easier than you realize. You've got a lot of advantages that maybe the younger students don't have. You've lived a longer life so far. You've learned probably a few more things. I think you're going to do great. That is really exciting. Holy cow. Fantastic. And biology, so paleontology, what I do, in some ways is kind of an unholy amalgam of geology and biology. Paleontology is the study of the history of life on Earth through the rock record, through the fossil record. So there's a lot of geology in there, but there's a lot of biology too. Some paleontologists focus kind of more on one or the other. I'm definitely much more on the biology side of things. So I think I'm right there with you, Cloven Art. Release the creature dinosaurs. What's that? love that Dilophosaur right there. That's really cool. That's some Spinosaurids. Oh, this is neat. And is this a Coelophysoid right there? A big old trike, a Spinosaur. Oh, I love the coelacanth there too. That's neat. This is super cool. Yeah. Awesome. Was that Diabloceratops there? No, Machairoceratops, close.
The land of the planet was clumped together in one
Very
vast supercontinent.
Freaky
Dinosaurs
feline.
occupied every corner of that world.
Thank you for the 4 months of support. I really appreciate that. Thanks for keeping me here online. Collectible cards. That's super neat, Dyson Dinosaur. That's very cool. Pretty nifty. Here's a link if anybody wants to see. And there's a trailer in Italian. Well, let's take a look at that. I don't speak Italian or
Il fascino
understand
per i
Italian.
dinosauri è senza tempo. Per più di un secolo chiunque ha inseguito questi straordinari animali preistorici in libri, film, fumetti
Here's
e
Gertie the
ovviamente
dinosaur
carte collezionabili. Per soddisfare questa
Meet this
continua
constant demand for
richiesta di
dinosaurs.
dinosauri,
Countless artists, starting in the
moltissimi
second half of the
artisti
19th
fin dalla
century,
seconda
tried to
metà
portray.
dell'Ottocento hanno provato a rappresentarli. Fu proprio in quel periodo che
Precisely
nacque
during
la
that time that
paleoarte.
paleo art.
Per pura coincidenza, sempre in quegli anni, vide
And you could probably make an argument that paleo art goes back a little bit further than that. But by pure coincidence,
alla
those
luce
same years
proprio
also
le
saw the
prime
birth of the very
carte
first collectible
collezionabili.
cards.
La paleoarte e le collezioni
Paleoart
dedicate ai
dinosaur collections
dinosauri
have therefore
dunque
gone
sono
hand in
andate a
hand in the
braccetto
present
fino
day,
ai giorni nostri, proponendo al pubblico una
offering
versione
audiences
sempre
ever-changing
diversa di
visions of
questi
these
animali,
creatures,
in base alle mode
shaped
e
by
alle
trends and the most
tecniche più
popular
in voga
techniques
a
of each
seconda
era.
delle epoche. Il main set di Release
The main
the
set of
Creatures,
Release the Creatures
Dinosaurs
Dinosaurs
è
consists
composto
of
da
150
150
cards,
carte, tutte
all
con
with the
la
same
stessa
rarity,
rarità,
and its
e
ambitious
si pone
goal is to retrace the 6
l'ambizioso
periods
di
of
ripercorrere
paleo
i
art.
6
Oh, this is
periodi
very
della
cool.
paleoarte, l'estetica dei più famosi
The
set di
aesthetics of the
carte
most
sui
famous dinosaur
dinosauri
card
e
sets, and of course
ovviamente
6
le
major
6 ere
geological eras in
geologiche
which dinosaurs
principali
lived.
in cui hanno vissuto.
6 major geological eras. So they don't mean era literally. That's probably a translation thing. But what would this be, like? Late Triassic, early Jurassic, middle Jurassic, late Jurassic. That's 4. Early Cretaceous, late Cretaceous? Is that the idea? Something like that?
I dinosauri del
Triassic
Triassico, i più
dinosaurs.
antichi della
Oh, very
storia,
cool.
sono stati disegnati da artisti che padroneggiano
Oh,
le tecniche
neat.
della
Is that
prima
Eoraptor
fase della
there? This is so
paleoarte,
cool.
il periodo eroico, che va dal 1830 al
The
1890,
heroic period.
come l'acquaforte, l'incisione sul legno
Oh,
di
this is
testa
really
e
neat.
l'uso virtuosistico dell'inchiostro. Facendo un passo in avanti si arriva al Giurassico inferiore e medio, soggetti dipinti a olio, a mezza tinta.
That was not Filippo right there, right?
In avanti si arriva al
No, that's not Filippo. Looks a little bit like Filippo, though. Subdivision of paleo art eras. Oh, so it's the paleo art eras rather than eras than time periods within the Mesozoic. Okay.
Giurassico inferiore e medio, soggetti dipinti a
Early and middle
a mezza
Jurassic.
tinta o pitturati sulle pregiate maioliche di
This
Monte
is
Lupo.
such a cool
Sono
idea.
le tecniche del periodo classico dal 1890
Classical
al
art.
1930.
Oh, this is so
Il
neat.
Giurassico superiore incontra il periodo moderno. Una
Late
tipologia
Jurassic
di
is the
paleoarte
modern
che fino
period.
alla fine degli anni 60 ha iniziato a sperimentare
So
con
it's
nuove
like we've got
tecniche,
a meeting of
composizioni
art history
e palette cromatiche
and paleo art and
una
dinosaurs.
sperimentazione che ha raggiunto il suo culmine
This is
con
so
l'avvento
cool.
del Rinascimento. Gli anni 70, 80, 90 fino al primo decennio degli anni 2000. I dinosauri diventano violenti e
Oh, very cool. And we see like William Stout influences here.
il sangue
this art.
sgorga, i colori si
Super
fanno
cool.
sempre più accesi.
Blood was flowing, colors grew more intense, and dense cross-hatching carved every muscle. The perfect style for the early Cretaceous.
Con il Cretacico
So that must have been Utahraptor right there. Yeah! Oh, this is cool.
superiore, invece, arriviamo ai giorni nostri e al cosiddetto periodo.
And is that Leptoceratops or somebody similar? Very cool. One of my
La
favorite
parola
dinosaurs.
chiave è libertà. Decine di tecniche
Yeah.
e stili, tutti diversi tra di loro, che
Oh, this is
incontreranno
so
ogni
cool.
tipo di gusto. E se questa libertà non bastasse, abbiamo deciso di immaginarci anche il futuro della rappresentazione dei dinosauri nell'arte e sulle carte.
Oh man, this is awesome.
Più folli e le idee più impensabili a servizio di quei dinosauri che hanno visto il meteorite che li ha portati all'estinzione.
Look at those Oviraptorosaurs. Oh, holy cow. You know who would love to see this? Would be Matt LaManna. He named Anzu Wiley-Eye. He would be astonished to see his dinosaur tattooed permanently on somebody's body. He would be so proud, you know? Oh man, this is cool. I should tell him about this.
130 artisti,
130 artists, 150 cards, ready to satisfy every taste, even that of the most demanding collectors. So really high quality art here. This is top tier stuff.
Contiene 8 bustine da
That's so
18
cool.
carte luna. Pacchetti giganteschi e pieni di sorprese per rendere ogni vostra sbustata
Very cool.
soddisfacente.
Yeah.
Se non vi basta la versione regular delle vostre carte preferite, infatti, è possibile trovare
Really,
un
really neat.
dinosauro
So I
in
guess you can
4
pre-order
versioni.
these now. Super cool stuff. Yeah, pre-order now. Very, very cool. Ora must mean like, well, like in Spanish we say ahora or ahorita, like now or right now. Ora is also the name for a Komodo dragon, which is funny too. But yeah, ahora, ora. See, Italian and Spanish, both Romance languages, both derived from Latin. Anyway, super cool stuff. And again, here's a link to this if anybody's interested. Thank you for sharing, Filippo. That's really neat. Yeah. Awesome. Lenina says dinosaur tattoos are rad. Lenina knows that from experience. Yeah. Anyhow. I'm glad you had a good stream, Filippo. Thank you for bringing everybody over. Here, let me play a quick welcome video for the new folks, and I can go get some water. Here we go.
My name is Danny Anduza. I'm a dinosaur paleontologist, and this is Paleontologizing. Science isn't just test tubes and beakers and white lab coats. What we're doing out here is science, too. We're testing hypotheses by excavating these fossils.
Join me for museum tours, interviews with other paleontologists, audience Q&A. Make Cacklin's work, 3D printing. It's pretty big. Who thought this was a good idea? And of course, live dinosaur digs.
A limb bone from a new duck-billed dinosaur.
I invite you to tune in and experience the adventure of fossil science. There you go. Yeah. Before I forget, before we do Metazua, let's post this to Blue Sky real quick. We've got some paleontology news. I'm pretty excited to cover today. Let's see. A new paper on dinosaur individual variation. What else did we have? Here we go. Alvarezsaur claws, dating molecular phylogenies, and Pinacosaurus morphology.
Like crazy, man.
together at twitch.tv/Paleontologizing. So it's spelled correctly. Working in the backdrop are 30 prints of
Like Big Daddy.
barrel pigeon. Barely visible, life-sized baby triceratops skeleton. Theropod footprint. Leatherback. Turtle model. And a sculpt of my beloved Trurarchonchus, along with other paleontological miscellaneous. Here we go. Good enough. Let's post it.
Hold on to your butts.
Paleontologizing. Looks like that's all spelled correctly. We'll try that link just in case. Yeah. And we had a question about leatherback shell keels. Oh yeah, for hydrodynamic purposes. Here. That's working. Excellent. That's working. Excellent. That's working. We're having some Dannyception here, looks like. 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 Here's a link to that post there if anybody wants to interact with it. Pugga Wugga says, which ankylosaur is that? Oh yeah, that's Euplacephalus right there. I don't have a Pinacosaurus, so Euplacephalus is the closest we've got in my 3D print menagerie. Yeah. Oh, and we gotta do Metazoa too. So let's do that. Before I go and forget, let's do some Metazoa. I was talking earlier about how paleontology gives us an opportunity to talk about a lot of other important scientific concepts, and one of the most important is that of phylogeny. Phylogeny is how living things are related to one another, making an evolutionary family tree to show those relationships, because as many lines of evidence show us, they all point to the same conclusion: all life on Earth is related. And we can draw those relationships as like a branching diagram, essentially a tree of life. Because all the evidence that we have points to the fact that every living thing on our planet descended from a common ancestor. All living things are related to one another. You go back about 3 or 4 billion years into Earth's past, you would find those single-celled organisms that gave rise to all other life on this planet. And because every living thing has common morphology to a certain extent and DNA in common, it shows that trace it all back to one last universal common ancestor. The game Metazoa kind of plays on that theme. There's a mystery animal of the day, and we gotta try and figure out what it is using an evolutionary family tree to narrow it down. And so, I forgot about the leatherback keels question. Well, remind me after we get through Metazoa, and I'll talk about that. But, yeah, let's dive in.
Hold on to your butts.
The way that this works is, we type the name of an animal into this box, and then Metazoa will show us the most exclusive, the smallest evolutionary group that includes our guess, plus the mystery animal. So if we get really close to the mystery animal, it'll be a very small group, not many species. If we're nowhere close, it'll be a really broad group with tons of species. But we narrow it down bit by bit, using our knowledge of the tree of life, using our knowledge of how these critters are related to one another. So So luckily we don't have to deal with all life, it's just animals for Metazoa. Down into that clade. The animal part of the tree is right here. Only about 1.4 million species. I usually like to start off with a mammal, because this game is kind of biased toward mammals. So give me the name of a mammal, a placental mammal, please. No marsupials, no monotremes. Mouse is often a good place to start, just because rodents are so darn species. Manatee, rhino, hyrax. Let's do manatee. I like that aquatica. With any luck, we're going to be maybe showing some manatees live on stream next week when I'm in Florida. So stay tuned for that. Yeah, both manatees and hyraxes are part of group Afrotheria. I'll show you. There's manatee here. Okay, interesting. Our critter is a eutherian, but not a manatee. Let's show you manatee on the tree. Jacob, how are you doing? Welcome. All right, here's manatees. So they are part of a larger group that we call Afrotheria. So along with the dugongs, they are the sirenians, the sea cows. They link up with the elephants right here. And then here's the hyraxes right there. So manatees, elephants, and hyraxes link up with things like aardvarks and sengis and golden moles and tenrecs. They are clade Afrotheria there. But our critter is not an Afrothere. Eutheria is the clade. These are the placental mammals. So, here, just do this manual. Endogenata, placental mammals. So honestly, manatee was not really a great place to start, but that's okay. Our critter is not going to be an Atlantogenatan, or else it would have said that. It's going to be a Boroeuthere. So these are the Laurasiatheres and the Euarchontoglires and other critters like that. Laurasiatheres, Euarchontoglires. So we could go in two different directions here. We could go with the carnivorans, bats, hedgehogs, and more, or with the rodents and primates and their relatives. So a camel's not a bad place to start. Yeah. Let's do camel next. We'll knock out the artiodactyls, let's hope. But maybe it'll still be a Laurasiatheres. Let's go with camel next. Let's try that. And, okay, our critter is a Laurasiathere, but it's not a camel, which means it's not an artiodactyl. So, here's the Laurasiatheres. Here's the artiodactyls. There's camels there. So, it could still be a Eulipotyphlon. Insectivores is what they call them on this tree. Or more likely, it's a scrotiferan. These are the carnivorans and the perissodactyls and the bats. Let's try a carnivoran. These are overrepresented in Metazoa. Like, there is a bias toward carnivorans. There's a lot of these guys that are in the Metazoa database. So give me the name of a carnivoran, Chad. It's dogs and cats and bears and weasels and seals. Coyote, says Fried Egg. That's good. That's a good place to start. Let's do coyote. Okay, our critter is a caniform. Excellent. So not a cat-like carnivoran, a caniform, a dog-like carnivoran, but we guessed coyote, which is a kind of canid, and it didn't say canidae, it says caniformia, which tells us it's not part of this clade. It's got to be over here, so it's a bear, or a weaselly guy, or a pinniped. So Yeah. So it's not going to be a fox, Buggo Wuggo. It's not part of Canidae. It could be a raccoon. We were going down this same path yesterday, and our critter yesterday was a kinkajou. Kinkajous are... There you go, right there. This is our critter yesterday. So it's funny, we're pretty close. The same small part of the tree. Our critter could be a red panda, or a mustaloid, or it could be a pinniped. I kind of want to try a pinniped, although it could still be a bear. There's 8 species of bear today. We've got black bear, brown bear, polar bear, giant panda. That's 4. Yeah. What about... Okay, seal. Sea lion. Walrus. What other pinnipeds are there? Probably it stands a higher likelihood of being a bear, I guess, just by the numbers. Let's try a bear. Mayor Space's elephant seal? They don't have that. No, it's not in there. They don't have spectacled bear either. Mayor Space, you're picking all the choicest critters. Mayor Space is getting fancy here. You know, maybe we should go with a mustaloid here, because there's so many. We've got weasel, we've got raccoon, we've got skunk, we've got ferret, we've got wolverine. I'm sure there's more I'm not even thinking of. Badger. Yeah. Mink. All right, Alex Vixen's very insistent we pick mink. Try that. And beavers are actually kind of rodent aquatica, so they're not related to these guys. Let's try mink.
Hold on to your butts.
And wait. Ho 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 ho. Okay. Our critter is a mustelid. It is a kind of weasel. It's actually within genus Mustela. Oh boy. Okay. Okay. The true weasels. 17 species. So this includes ferrets. I don't think stoat is an option, right? No. Ferret is an option. Weasel is an option. All right, so we're gonna run a poll here. Should we go with ferret or should we go with weasel? It's up to you, chat. Ferret. Weasel. Start poll. It's up to you. So far, ferret is winning. 5-2. Oh, weasel is pulled ahead. 7-5. Holy cow. Votes are coming in from Weasel County, it seems. Although ferret is starting to catch up a little bit. It is 8-10. Oh, Ferret is pulled ahead, 11-10, by 1 vote. Might have to go into recounts for this. Weasel fight back, says Fried Egg. Here, we're gonna play our fighting music. All right, it's tied, 12-12. Don't do this to me, chat. Don't do this to me, chat. Ah! Okay, let's do... Time to flip a coin, says Petrodactylus. Do we win? No. We've all lost, Canyon Arrow Boy. We've all lost. Let me go get a coin. Luckily, there's a penny on the floor. All right, let's say heads is ferret, tails is weasel. You ready? It's heads for ferret. Okay. Oh, sorry, 14-14. I'm not a mathematician, Kaori, sorry. But yeah, the final tally is 14-14. Yeah. Okay, we're gonna go with ferret. You ready?
Hold on to your butts.
And... That's it! Yes! Oh! Excellent. Yeah. Fantastic. We've done 5 guesses. That's pretty good. That's pretty good. That's gonna help out with my average here. Not bad. And post. Took me 12, says Sharkgeek. I'm still new to Metazoic. You'll get the hang of it, Sharkgeek. Yeah. One of the things I love about this is that it encourages what we call in evolutionary biology tree thinking. So, tree thinking basics. This is from the Understanding Evolution website, which is an extraordinary resource for teachers or for people just trying to learn. Oh, we have a video.
Evolutionary Synthesis Center and Understanding Evolution. This is an Evolution in the News supplement on tree thinking.
So this doesn't have anything to do with being an
Phylogenetic
arborist.
trees represent relatedness, or who's related to whom and how closely. Phylogenetic trees come in many shapes and sizes and may be based on various kinds of data, including molecular, morphological, and chronological, but they all represent relatedness.
A fundamental concept in trees is the passage of time. In all the trees, time progresses outward from the root toward the tips of the...
Anyway, we'll be talking about this a lot today, actually, because we've got one of our papers we'll be discussing is on trying to date molecular phylogenies. So when we're using DNA to build a phylogenetic tree like this, an evolutionary family tree, how do you account for time? That turns out to be really important. So anyway, I did it on my phone. Oh yeah, so you're at a distinct disadvantage there, Sharky, if you're doing it on your phone. But yeah, and Aquatica, you and me both. Yeah, yeah. Anywho, let's, before I get into that question about leatherback keels, please, let's watch a quick video on ferrets in honor of Metazoa today. let's take a look at this from PBS News Weekend.
50 years ago this month, President Richard Nixon
And this is from 2 years ago.
Signed the Endangered Species Act into law. One of the first on the endangered list, the black-footed ferret, North America's rarest animal. It was once thought to be extinct, but thanks to...
Hang on, that's not going to be North America's rarest animal. Maybe, no, not even rarest mammal. Who can think of some critters that are more rare than a black-footed ferret? Just for the sake of going, oh, well, actually, there's some creatures that are fewer in number in North America. Who can tell me a critter? Charlie's Dragon with the Vaquita, yes. Intelligent humans, oh boy, Sharky. Devil's pupfish. That was my first thought, Aquatica. Yeah, from Devil's Hole. Red wolf, they might be rarer, and jaguar are the ones in North America. There's a good number of them, Petrodactylus. Kaibob squirrel, I've never even heard of that from down the mountain. Interesting. Yeah. Axolotl in the wild. Yeah, there might only be a few of those left, huh? Florida panther. Yeah, so Florida panther is a tricky one because that is like a population or even a subspecies. So when we ask a question like this, like what is the rarest animal in North America, we have to define our terms. When we say rarest animal, are we talking about at the species level? Or could it be a subspecies or a particular population? Key deer, pretty rare as well. So very cool. You got to see one, Sharky? Awesome. But are key deer a species? Or are they a subpopulation or a subspecies? Endangered subspecies of white-tailed deer. So this doesn't make them any less special or worthy of protection. But there are at least other white-tailed deer around, members of the same species. These ones are just cool and unique. They live in a particular part of Florida. Same, I think, with the Florida panther, which should be Puma concolor, right? Yeah. Puma concolor, couguar, Florida panther. And this isn't even a subspecies, it's just a population of pumas in South Florida. But anyway, yeah. And silverfish, I think, are not actually fish, Dan the BC man. Yeah, they're insects. Yeah. You might be thinking of the desert pupfish, maybe. Or the Devil's Hole pupfish is what I'm thinking of. Yeah. So they only live in one particular pond, a deep hole in the desert. How many of them are left? Population counts have peaked at around 550 individuals since 1972. Only about 38 fish remain as of spring 2025. So these are certainly more rare than black-footed ferrets. My professor is one of the people who worked on... Very cool, Derek the marine biologist. That's awesome. Oh man, I'm jealous. I'd love to be able to 3D print one of these, actually. I wonder if, let's see. So you can, there's a commercially available model that you can buy, but I think it would be really cool to be able to actually print one. Maybe you print it really big. Huh. I guess Little Critters makes one. Yeah. Miniature porcelain figure. If anybody's interested. I would hope that some of the proceeds from this would go toward their conservation. I have the leatherback turtle hatchling one. Not a toy, it is ceramic. Display only. About us. Do any of their proceeds go toward? To inspire people's awareness of the value of wildlife on our planet. Cool. It doesn't look like any of the proceeds go toward conservation, which feels like a missed opportunity. That is really cool, Derek the Marine Biologist. Yeah, that endemism. That these creatures evolved to be so unique when they're so close geographically, but if they're split apart, like if they're reproductively isolated, then you can get that kind of uniqueness that develops between. It's so cool. Anywho, let's get back to black-footed ferrets. You know, it's not a competition. There's lots of creatures here in North America that are worthy of our admiration and support and conservation. These are our natural neighbors, you know? Be it a devil's hole pupfish, or a California condor, or a Florida panther, or a black-footed ferret.
50 years ago this month, President Richard Nixon signed the Endangered Species Act into law. One of the first on the endangered list, the black-footed ferret, North America's rarest animal.
And what's kind of fun, like, not to get too political about this, but like Richard Nixon signed that into law. How much worse have things gotten that, like, you know, quintessential evil president? Our evil presidents today are so much worse than that. Like, at least Nixon did cool stuff like that. Can we just have a crumb of something good for once, you know?
It was once thought to be extinct, but thanks to the dedicated work of conservationists, it's making its way back. We went to see some of that work for this report, part of our ongoing series, Saving Species.
There is a lot riding on these squirming, squeaky newborns. They're black-footed ferrets, and whether they thrive will go a long way in determining whether their species will survive.
The black-footed ferret has a lot of pressures out in the wild. They're flagship North American carnivore species. They absolutely have a critical role to helping maintain the balance of the ecosystem. We try to look at each individual kit every day if we can.
Adrienne Crozier is in charge of the breeding program at the Smithsonian Conservation Biology Institute. Her goal is to produce enough of this rare member of the weasel family to help stock breeding programs around the country and reintroduce them into the wild.
So every enclosure either has a single adult or a family group. So for example, this is Stinkpot, and she has 7 babies.
Stinkpot. I wonder if they do produce a smelly musk. A lot of mustelids will do that. Skunks, most famously. But Stinkpot is also the common name of a reptile. Does anybody know what kind of reptile? A stinkpot. What's the broad group of reptiles? Somebody should know this, right? I don't think this is that. Yeah, stinkpot. It's a common name for a kind of reptile. I think Shark Geek might have an inkling. Let me show you. Here we go.
I like turtles.
It's a turtle. Let's see. Sternotheris odoratus. I guess it's pretty odoriferous. Known as the common musk turtle, eastern musk turtle, or stinkpot turtle. Due to its ability to release a foul, musky odor from scent glands on the edge of its shell. These guys also, I think, love to climb trees, if I remember correctly. Yeah. It's pretty wild, but they're surprisingly good climbers. Yeah. This might be a big-headed musk turtle, but members of this group, they really like climbing. It's pretty funny. There's a loggerhead musk turtle there. Yeah. I wonder how they get down. You know? Imagine a smelly turtle falling on you. It happens, I'm sure. Yeah. Do they jump? Maybe you have to call the fire department. I don't know. Not something I expected. Turtles climbing trees, says Charlie's Dragon. They do that. They do that. In fact, that article might even talk about that. Yeah, it can climb sloping, partially submerged tree trunks or branches. Has been known to drop into boats or canoes passing underneath. It's a poor swimmer, interesting. And most often be found walking along the bottom of its native habitats. Swamps, marshes, ephemeral pools, river springs. Yeah. Anywho, back to our ferrets. It's funny that that individual got called Stinkpot. She must have been kind of smelly.
So for example, this is Stinkpot, and she has 7 babies.
We visited Crozier during the birthing or whelping season. She introduced us to all ages of baby ferrets, which are called kits. We can see some of the babies
they're peeking out.
Oh.
They're getting really big now, and they already look like little adult ferrets.
And now is Stinkpot not coming out because she wants to protect the kits?
So that's her box, that's her territory. She keeps all the kits in there.
Each day, the staff carries out a carefully choreographed routine to separate the kits from their mothers for inspection. After they've been checked out and placed in a fresh, clean box,
Gonna pick it up, and she just goes right back in.
the kits are returned.
I love that. I think we need an instant replay of that right there. This reminds me of like at the bank or the hardware store, where they like put a slip of paper into the pneumatic tube system. They go, foomp, it goes.
Placed in a fresh, clean box.
It's gonna pick it up, and she just goes right back in.
The kits are
One more time.
And placed in a fresh, clean box.
It's gonna pick it up, and she just goes right back in.
The kits are
That's so
returned to
funny.
their mothers, who sometimes give the caretakers a piece of their mind.
Oh.
We helped check out Series 6 kits, just a few weeks old. They're unable to see until they're about 35 days old.
So we just look at them every day to make sure that everything looks normal, their eyes look normal, there's no swelling or scabbiness or crustiness around the eyes. Make sure everybody is
No
nice
crustiness
and
around your eyes? No.
vigorous.
Good. That's good.
These guys seem very sleepy.
Yes, I was just going to say, this one is just curling up to go back to sleep.
When it was over, this mother quickly moved her kits from one box to another, doing her own maternal head count. Nestled in the foothills of the Blue Ridge Mountains, the Conservation Campus in Front Royal, Virginia, uses reproductive technology to breed species from cheetahs to black-footed ferrets. Crozier says the ferret's size requires them to do some improvising.
Because they are so very small, we really have challenges finding tools and instruments that we can use on what may be only a 700 or 800 gram female. So we have to get really creative, and we've bought some special tools that are actually made for pediatric surgery so that we can try to improve our success in artificial insemination in the species.
Black-footed ferrets.
So if you want to learn more about black-footed ferrets, and if you're not yet following science streams, well, you're missing out. So Balint and Lita are both geneticists, molecular biologists. They're very interested in black-footed ferrets because given that these critters have become so rare, there's so much of a genetic bottleneck. You got to be really careful about how they breed, so that you don't get inbreeding, you don't get genetic defects and stuff like that. Balint and Lita have talked about black-footed ferrets many times on their channel, and interviewed some black-footed ferret researchers, and they have black-footed ferret emotes as well. There you go, Lenina. Thank you. Yeah. Wholesome as ferret. Exactly. Yeah. So these ferrets are very much recurring characters on that channel. So go give Science Streams a follow if you appreciate these critters. And I should be appreciating my landlord here. This is Minnie Pie. How are you doing, Minnie? Huh? Yeah. You having a good day? I hope so. I hope so. Yeah. So Minnie Pie is on the opposite side of the caniform, or the carnivoran family tree from ferrets. Ferrets are caniform carnivorans. So they're more closely related to dogs. And Minnie Pie here obviously is not just related to cats, she is a cat. Ugh. Yeah. Huh, Minnie Pie. Yeah. It's true. Do you want some treats? Is that what this is about? We're gonna get paid. Yeah, it's a collection time. Rent is due. Okay, we can make that happen. We can make that happen. Yeah. Ooh, what's in here? Oh yeah. Is that to your liking? How about that one? Yeah, good stuff. How about this? Break that one in half. You seem to like them when they're smaller. Stuff? Alright. Some more. You're dropping crumbs and saliva all over the desk. All over the desk. All over. Yeah. Look, there's more if you want to eat it. No? No? Okay. You want to hang out and we'll talk about ferrets, Minnie, or no? You're gonna go? Okay. Well, ladies and gentlemen and NB's Minnie Pie. Let's continue with our ferrets here. I'll clean up. There we go.
Were first put on the endangered species list in 1967, and then in 1979, when the last known member of the species died in captivity, they were declared extinct. But 2 years later came a surprising discovery made by a Wyoming ranch dog named Shep. He took a dead black-footed ferret home to his owner. That led to the discovery of 24 black-footed ferrets alive and well in northwest Wyoming. All members of the species known today are descendants of that group.
This is one of the kind of historic mementos representing the pedigree of the first couple of years of black-footed ferrets in the breeding program.
Paul Marinari knows the family tree like the back of his hand, all the way back to the original, Mom.
Actually, that is Mom right there. You can see the reason why she was called Mom is because this was a litter that she had in the wild. So when she and her offspring were captured from the wild, we had to make certain assumptions of who the dad was. That is Scarface. And he was actually the last black-footed ferret to be captured. He was quite prolific.
You know, a more corny streamer would make a joke about, you know, say hello to my little ferret. Not gonna do that. Not going to.
And he was actually the last black-footed ferret to be captured. He was quite prolific when it came to breeding, very overrepresented in the population.
Marinari is the keeper of the Smithsonian's black-footed ferret stuff.
We're above that here. Exactly, sure. Yeah.
Do an overall body check.
Most of his career has been spent studying the species. For 16 years, he was director of the U.S. Fish and Wildlife Service's Black-Footed Ferret Conservation Center in Colorado.
We have a very stable breeding population, around 300 individuals. The wild population is precarious in places. There are several populations that are doing really well, and we estimate that there's between 300 and 400 black-footed ferrets living in the wild. It's kind of the perfect species to deal with.
Petronectalis is, what was the red thing he was holding? I don't know, actually.
300 individuals. The wild population stable.
Conservation. 16 years he was director of the U.S.
I almost wonder if that's like a pit tag reader or something, but I don't know.
U.S. Fish and Wildlife Service's Black-Footed Ferret Conservation Center in Colorado.
We have a very...
I don't know what that was. I'm not sure. And yeah, that was my thought too, is like a chip scanner, but I don't know. I don't know.
Population is precarious in places. There are several populations that are doing really well. And we estimate that there's between 300 and 400 black-footed ferrets living in the wild. It's kind of the perfect species to deal with a breeding program and a reintroduction program, because they don't live that long. They are very quick to produce offspring. They produce a fair number of offspring. That's the simple version. Saving the species is much more complex.
That complexity comes in part from the black-footed ferret's relationship with prairie dogs.
Yep, and I was just looking at my log of a prairie dog this morning. On iNaturalist. It was just, hang on. Here, let's zoom in, because I know this was in Utah that I logged this. San Was. Butterflies. Where did I see the prairie dog? It's gonna be in blue, huh? It's a mammal. But I've been no, blue or reptiles maybe? Lizard. Pied blotch lizard. There we go. There is my prairie dog. Okay, that makes sense. I've been lucky enough to see prairie dogs in the wild on a bunch of occasions, and even managed to get a pretty good photo of one at one point. Right there, this would have been a couple years ago. No, last summer, shoot. Yeah, so this is on the way back to camp in Utah, where I go out and dig dinosaurs at the Utah Geological Survey. Pretty cool. Yeah. Lenina says, I downloaded iNaturalist. I just need to remember to use it. I spent some time on iNaturalist this morning. I'm really looking forward to logging a whole bunch of different critters out there in Florida next week. But, yeah. Pretty cool. I love iNaturalist. I'm hoping to do some iNaturalist-focused streams in the future, but for now, let's continue with our ferrets and their primary prey, prairie dog,
which make up 90% of their diet.
They require prairie dogs to thrive. They require prairie dogs for their burrows, for their homes.
They are canids. You're right, airspace.
Primary prey source. The prairie dogs are not very popular with the farmers, especially because they do so much damage to the farmland. And so the prairie dogs are actively...
What do you mean farmland? That's prairie dog habitat. You're trying to grow crops on it? That's some, like, yeah, let's cause a dust bowl kind of thinking there.
Removed from farmland, which means the ferrets don't have a home, the ferrets don't have prey.
Prairie dogs are a keystone species, the glue that holds a habitat together. But many ranchers and farmers in the West consider prairie dogs pests to be eliminated.
I was going to say something about how it sounds like they're projecting, but I'm not going to say that. We're going to be nice today.
But many ranchers and farmers in the West consider prairie dogs pests to be eliminated. In the early 1900s, widespread poisonings were commonplace. If you don't have prairie dogs, you won't have ferrets. And if you don't have ferrets...
So it's a balance, and they're all occurring naturally, and they should all be occurring naturally, and keeping each other in balance. But if you take out one piece of that, which is usually caused by humans, then everything falls out of balance. And then we have complete loss of species. But anytime you have an extinction event like that caused by human intervention, obviously we're doing something really catastrophic to the ecosystem.
The prairie ecosystem once covered 1/3 of North America, stretching from Canada to Texas.
Hardly any of it is
left. Since the late 19th century, it's shrunk by 62%.
Well, I mean, it's shrunk by 99.9%, at least in terms of like untouched prairie ecosystem, where you actually have proper prairie grasses with the roots that go down 3 meters into the ground, you know, like teeming with native species. That sort of habitat is nearly entirely gone, you know?
We can save the black-footed ferret. Our thought, and all of our partners' thought, is that we can save the other 130 unique plants and animals that are native to the North American prairie. And it's a pretty special ecosystem, one that's often overlooked because of the riches we have in our country.
Nobarum says, do we have info about how many animals humans really hunt until extinction? That's debated. So it might be thousands of species now at this point. It could be like as much as, what was it, like 1/5 of all bird species have been hunted to extinction by humans, or wiped, just killed off by introducing invasive species. Like, that's the thing, is that there are still new species of bird being discovered that are recently extinct, in the sense that, especially throughout the Pacific, throughout all of these remote islands, like, people will find subfossils, which are, they're like bones that are on their way to becoming fossils. They're not there yet. They're too recent. They're fresh, essentially. Well, not fresh, but they're not fossils yet. They haven't been fossilized. That shows that, oh yeah, well, this island had this species of bird and that species of bird and all these other species of bird that are no longer there, because when people showed up, they killed the birds, they took their eggs, they introduced rats and pigs and other invasive species that would eat the eggs of these birds. And so it's a crazy number of bird species seem to have gone extinct when people spread throughout these island chains in the Pacific, especially. It's harrowing to think about, you know? Yeah. There was a paper about this not too long ago, actually, and I'm trying to find that real quick. Let's see. Is it here? There we go. Yeah, from 2023. There we go. Undiscovered bird extinctions obscure the true magnitude of human-driven extinction waves. Here's that paper here. And here's a link to it if you want to look at it yourself. It is open access, no paywall. But yeah, it's estimated that... how many? Human expansion across the planet is classified into 4 major waves. Yeah, we suggest that at least 1,300 to 1,500 bird species, about 12% of the total bird species in existence, have gone extinct since the late Pleistocene, with 55% of these extinctions undiscovered, not yet discovered, or left no trace. Just astonishing. Like, over 1,000 species of just of birds. This isn't even counting other reptiles, endemic mammal species, invertebrates. Yeah. Nuts, you know?
The study suggests that at least 1,300 to 1,500 bird species, 12% of the total, have gone extinct since the late Pleistocene, with 55% of these extinctions undiscovered. The Pacific accounts for 61% of total bird extinctions. Bird extinction rate varied through time, with an intense episode in 1300 CE, which likely represents the largest human-driven vertebrate extinction wave ever, and a rate 60 to 95 times the background extinction rate.
So anyway, yeah, I wish we could find a better video than that. That's all I've got. Yeah. Nuts. Anywho, yeah. A creature that we can save, that is, its numbers have dwindled, but, you know, we can save it, as the black-footed ferret.
Another threat to the black-footed ferret? A bacterial disease called sylvatic plague. Both black-footed ferrets and the prairie dogs they eat are highly susceptible to it. It's transmitted by fleas and has been known to infect humans. Black-footed ferrets are nocturnal, spending daylight hours in burrows dug by prairie dogs. Their lives there have largely been a mystery to scientists.
Cutting the strap.
But this summer, field biologists in Montana began the first ever tests of electronic devices to track prairie dogs underground. They're like Fitbits, mapping their movement, providing researchers with a wealth of data they hope will give them a better understanding of how the...
I love that. So this is a really... I love this interface that they have here. It's like showing them moving through these tunnel systems like that. And then, like, here's the orientation of the critter. They didn't have a prairie dog, I guess, in their assets folder, so they just have, like, a little 3D bear right there. That's This is so funny. I
track
love this.
prairie dogs underground. They're like Fitbits, mapping their movement, providing researchers with a wealth of data they hope will give them a better understanding of how the two species share the networks of tunnels called towns.
I mean, prairie dogs and bears are both caniform carnivorans. So they're part of the same, part of the same group. They tend to differ a bit in size, but yeah.
For the first time, we'll be able to map that and know how deep it is, what are the densities of the animals, what is the space that one black-footed ferret is actually using out of that town, and what is the overlap between those ferrets, so we can know what would be the carrying capacity of a given prairie dog town.
And cryogenic technologies allowing scientists to freeze black-footed ferret DNA in state-of-the-art genome resource banks.
Nice. So again, Science Streams, let's get another shout out for them. They talk about this sometimes, and I think they might even be interviewing some more black-footed ferret researchers at some point in the near-ish future. Go give them a follow.
In 2020, researchers used the frozen cells of a black-footed ferret that had been dead for 30 years to produce the first ever cloned member of the species, Elizabeth Ann.
Yeah, and Elizabeth Ann Balint and Lita have talked about her a lot on their channel. This is the thing, when you've got so few individuals, you don't have a lot of genetic variation, and you got to make sure that you're not having like inbreeding and stuff. And so being able to clone black-footed ferrets who lived in the past, you can use some of their genetic diversity to help make the living population that much more resilient to disease and deformities and things like that.
So Adrian, this is your breeding board?
Yes.
Most of the mating comes naturally, but some ferrets need a little encouragement.
So we try to mix and match younger, naive males with older, proven females, and vice versa.
27.5.
As a new generation of black-footed ferrets weighs in, the staff at the Smithsonian Conservation Biology Center feels the weight of what's at stake.
So you go from the species that's thought to be extinct to all of a sudden, holy cow, we have the species, we have to take care of them. The fate of the species is in our hands. That's a huge responsibility. People can make a difference, and I think that is something that is important for people to hear.
Exceptional measures to save a small but vital piece of our ecosystem.
Yep. Cool stuff. Here is a link to that video there. And, who was asking the question about leatherback turtle keels? Are you still here? I hope so. I know it's been a while. Let's get into that. So when we're talking about these animals, Jacob says, that's so sad. Hopefully the program works out well. I'll tie this into leatherback turtles. Black-footed ferrets are at least lucky in the sense that they're very charismatic animals. This is something we were talking about yesterday briefly. Charismatic just means that, like, people really like them, you know? Black-footed ferrets are very, very cute. They're fun to watch. They're easy to relate to. You know? People look at these critters and they want to save them, you know? The systems and institutions that we as human beings have built. These systems that exploit the natural environment and try and turn prairie habitats into, like, essentially factories for producing food for our other animals that we, you know what I'm talking about. Like, intensive agriculture has nearly doomed these critters. But, like, on a individual level, like, we as human beings, we tend to love critters like this. More so than, like, I don't know, a native species of beetle or something that might also be threatened. or particular species of fungus or lichen or a kind of prairie grass or something. Those are all very important too, but they don't have the charisma of something like a black-footed ferret. People love these critters. They get excited about them. They want to do everything that they can to protect them. That's a good thing.
See that my 50,000 a year has been well spent.
Sophie, thank you for the 45 months at tier 3. Holy cow.
Lanadic Sparkle
Oh, I
3.
appreciate that. Thank you, Sophie. Thanks for support what I do here. Tier 3 is a big deal, and I appreciate that tremendously. 45 months is nothing to sneeze at either. We're lucky that people get so excited about these critters that they can become kind of a poster child for conservation. And that's the thing, is that if you manage to prevent these critters from going extinct, if you go out there and you preserve their habitat, you protect them, they kind of act as an umbrella to also allow other creatures to thrive. Creatures like prairie dogs and various species of invertebrate, and lots of different native prairie grasses and wildflowers and things like that. If you save the black-footed ferret, you've helped save the prairie ecosystem in general. And it's the same deal with leatherback turtles. It's one of the reasons I'm so excited about these critters. I mean, A, they're incredibly cool. They're such charismatic animals. But there's that similar, like, charismatic umbrella effect there. Where if you manage to save these animals, that means you're also protecting these pelagic environments. Leatherback turtles live way out in the open ocean, and the females, I guess, and the males too, will go close to these nesting beaches to hang out. As the females are going up to lay their eggs, the males will breed with them there. But there's so many different threats that face them. They get caught in fishing nets and on fishing lines. They get hit by boats. I saw a really shocking photo today of a dead leatherback on iNaturalist, like a full-grown adult, huge individual, must have been over 1,000 pounds. It had been cut clean in half. Like basically right at the waist, or like, mid-carapace, mid-plastron, by a giant boat propeller, and it was just floating there on the surface. Somebody took a picture of it and logged it. So shipping traffic is also a big threat to these guys, and building of nesting beaches and putting all these lights near the shore confuses hatchlings. There's so many different things that threaten these creatures who've been around since the Cretaceous period, The ancestors of modern leatherbacks were swimming around in the oceans when dinosaurs were walking around on land. But if we're able to save these animals, that also means that we've saved a bunch of other species that benefit from the preservation of their habitats, the reduction of fishing bycatch, the preservation of beaches. Climate change is another threat to them. If we nip that in the bud, we won't just have saved the leatherback, but so many other species too. So this creature can be a kind of an ambassador for its environment and all the other species that live alongside it. That's one of the reasons why I'm so excited to work with these critters and get people excited about them, because if we save the leatherback, then we've kind of saved the world. These creatures that swim across entire ocean basins, they're in the water and they're up on the beaches. They require a lot of protection, but it's all worth it, and we won't just save the leatherback, we'll save countless other species too. I hope that makes sense. And there you go, Digital Seahorse. Yeah. Turtles all over the world are actually threatened. It's not just sea turtles. And I'd like to recommend a book to you actually about that real quick. This is written for a popular audience, but really well written. The prose is excellent. Beautiful writing. You'll learn a lot from this. It's called Of Time and Turtles, Mending the World Shell by Shattered Shell by Cy Montgomery. One of my new favorite authors. But she links up with a bunch of people who rehabilitate wild turtles who'd been hit by cars or otherwise mauled by dogs or shot by cruel people with guns. Turtles are remarkably resilient animals if you just give them half a chance. Even a turtle who's had her spine severed because she was run over by a pickup truck. You care for her and give her just a little bit of medical attention, she might heal and she might walk again. And there's lots of stories in this book about precisely that. Turtles that you were sure would die from their injuries. And with just a little bit of tender loving care, these critters can bounce back. And that's sort of a metaphor for turtles in general and for nature in general, you know? Just a little bit of thoughtful care and get recovery. Things can bounce back. Reason for hope. Yeah. Anyhow. Good book. I'd recommend it. And no barm. Yeah, so leatherbacks are really important. They actually help reduce the numbers of sea jellies, who sometimes can have these population booms and crashes. Leatherbacks and a few other species, like molas, can actually help regulate jelly populations. Yeah, leatherbacks will feed on jellies, as you see here. Here's a camera strapped to the back of a leatherback, and they can eat a lot of jellies. Some of them can eat maybe their body weight in jellies in like a day. It's pretty incredible. And Tone Rebellion, thank you for the 21 months of support.
Supposedly, a tortoise named Manuela, later found to be male, went missing in 1982 and was discovered alive in 2013 inside an old speaker in a family's storage attic in Brazil.
That's bonkers. Yeah, it's remarkable what's these critters can do with just a little bit of room. Remarkably resilient animals. But we don't know why they don't get stung, Puggo Wuggo. It's a really good question. And,
Over the past 2 decades, jellyfish have begun to overwhelm our oceans. In New Zealand, divers swat off millions of stinging jellyfish, each no larger than a grain of pepper. In Sweden, a massive cluster of moon jellyfish shut down one of the world's largest nuclear reactors by clogging the plant's essential pipes. And in the Sea of Japan, thousands of 200-kilogram Nomura's jellyfish with bells 2 meters in diameter.
That's like 7 feet across. That's nuts. These are huge creatures.
Swarm fishermen, snapping nets and devouring local fish. Around the world, these animals voraciously consume fish eggs and larvae, routinely undermine marine farming efforts, and outcompete adult fish by consuming the resources they need to survive. If things stay on their current trajectory, we could be headed for a future where the entire ocean is thick with jellyfish.
And so jellyfish are important components of these ecosystems, but thanks to climate change and pollution and overfishing of the oceans, they're taking over. And this could, if these trends continue, this could spell doom for the world's fishing industries, you know? Imagine that, like, no more fishes in the oceans. It could happen.
So, is there anything that can keep these gelatinous creatures under control?
Yes.
Enter the humble sea turtle. There are a wide range of marine animals that feed on jellyfish, but sea turtles are among their most ancient predators. And while every known species of sea turtle preys on jellyfish at some point in their lives, none consume quite as many as the leatherback. Leatherbacks are the largest species of sea turtle, and they eat jellyfish almost exclusively, devouring.
This was our world 225 million years ago at the beginning of the Mesozoic era.
Thank you, Danny, for keeping me learning.
Thank you for keeping me online with the Prime there. Go for Fluffernutt. I really appreciate that. Thanks for spending your Prime here. That is excellent, and I deeply appreciate it.
Well over 1,000 metric tons of them over their roughly 50-year lifespans.
So yeah, that's 1,000 metric tons. That's 1,000 times 1,000, because a ton is 1,000 kilos, a metric ton. So that's 1,000,000 kilograms of jellyfish in their lifetime that a single leatherback can eat. That's extraordinary, you know? Yeah.
This is particularly remarkable because jellyfish are 95% water and very low in calories. So to maintain a healthy weight, the average 500 kilogram leatherback needs to eat roughly 400 kilograms of jellyfish every day. That's roughly
400 kilos. Imagine eating 400 kilos of jellyfish, of sea jellies in a single day. It's like eating a grand piano, you know? That's bonkers. That's insane, you know? But they do it. They're incredible animals.
the same weight as a grand piano. And while some sea turtle species have been documented selectively eating their prey's protein-rich gonads, leatherbacks eat jellyfish whole, mowing down huge swaths of unsuspecting jellies. Normally, jellyfish aren't quite this defenseless. Most species have tentacles covered in cells called cnidocytes, which contain venomous harpoons coiled and ready to launch. These barbed structures, known as nematocysts, are released on contact. Jellyfish frequently use this sting to paralyze and kill their food, and it can also irritate the skin of would-be intruders.
Has anybody here in the chat ever been stung by a jellyfish before? Ever had these stinging nematocysts of a jelly get you? Not fun. This happened to both Ios and Lordy. Just little tiny sea jellies. We were in Puerto Rico last May. Yeah, Lordy says yes. Yeah. So it's extraordinary. We don't know why these don't hurt leatherbacks, but that's yet one more reason to save them, because shoot, these critters should be studied. Maybe there's some secret lurking there in their anatomy or physiology. We can learn from them. Why do they not get hurt by these?
But it's completely useless against sea turtles. Most of these reptiles have thick scales covered in keratin.
Leatherbacks don't, though, which is wild, because they're the ones who specialize in eating jellies, and they don't have this.
The same material that makes up nails and claws. This leathery armor protects their skin while they hunt, and any captured prey that tries to escape is in.
So again, I want to emphasize, leatherbacks don't have that. They don't have beta keratin at all. They're the only reptile on the planet that doesn't have beta keratin. Why? You know, we don't know. There's something going on there, you know?
Impaled on the keratinized spikes lining the leatherback's esophagus.
Yep. And so somebody was asking, like, they must have crazy fast digestion, right? No, actually. They don't. Instead, they have a crazy long esophagus. So the esophagus is it's not your windpipe, but it's your food tube, you know? And in humans, it's what, like, maybe 18 inches long, something like that, at the most? Probably less. I don't actually know. About 10 inches? 10 to 13 inches long in most people, your esophagus. You know, esophagus. It's a fun word to say. It goes from your throat down to your stomach. In a leatherback, it is so much longer, and it doesn't just go from the throat to the stomach. It takes a detour, which is incredibly cool. I'll show you some footage of this. It's going to be a little bit gross, so if you're squeamish like I am, maybe peek through your hands and through your fingers at this. There we go. But I'll show you those papillae, and so here's a video. It's a dissection of a leatherback turtle. We watched this before we interviewed Dr. Jeanette Weineken a few months ago.
And then when you go inside, there's more pointiness. All of this is actually quite bizarre. All of these pointy things here are going to help push the jellyfish down, keep them from coming back up. It's a one-way trip. And not only does it start right here at the mouth, but it goes all the way down the esophagus and all the way down to the stomach.
Yep.
Jellyfish have been roaming the seas for over 500 million years. They're found in every ocean, from the shallows to the deep, and can gather in blooms 100,000 strong. These tentacled beasts are amongst the most venomous creatures on Earth. So with all the seafood to choose from, it's odd that turtles developed a taste for them. Why turtles are immune to the sting remains a mystery.
Yeah.
But what's remarkable is how leatherbacks can fuel their giant bodies on this diet.
Because it's so
There's not
unnutritious.
much to a jellyfish. It contains 95% water, so it's a bit like eating nothing but cucumbers.
Those are not teeth at all, Case Kuchin. No.
Can I have a little feel inside here? Because I want to feel what it's
That's
like
the
to be a
esophagus.
jellyfish.
Yeah, be careful if you try to come back out. It's
Yeah, no,
very sharp and pointy.
That is really
It's a one-way
weird.
path, Mark. You might not be able to get your hand out easily.
That is weird.
Do I have to cut you out?
That is very, very strange
These are
feeling.
very, very sharp.
We're going to follow the length of the deeply strange digestive system to find out how the leatherback manages on such a low-energy diet.
So if we follow that underneath the windpipe or trachea, we see just the esophagus.
Oh, their trachea, by the way, is ringed with cartilage. So their trachea, their windpipe, is semi-rigid, so it doesn't compress at depth, because these guys will dive down 4,000 feet. We're like over 1,000 meters. And their lung is completely compressed. Their shell compresses, but their esophagus, given that it's lined with rings of cartilage, it doesn't completely compress. They're able to hold a little bit of air in there, and then also as their lungs compress, it kind of forces oxygen into their muscles and everything, into their muscle tissue, and that's how they're able to avoid getting the bends. They don't get decompression sickness like scuba divers can get, and it doesn't crush their windpipe because it's got that cartilage. Really, really cool.
Esophagus right here, and we're going to follow that underneath the heart. We're going to pull that to the side. So as it runs under the liver, you can see my hand emerging again here. There's a continuation of the esophagus right here. So it continues
the esophagus
around
goes
this corner like this,
from the throat,
comes back up here where the propeller had cut
back
through
to the
esophagus, so you
hips,
still see those pointy things in
and
the
then
esophagus
back
here.
loops around to the front of the body
Around
to go into the stomach.
here, goes again under this piece of liver, and eventually
Nuts.
ends up in the stomach, comes back around on this side.
Bonkers.
It turns out the leatherback has an extraordinarily convoluted digestive tract.
Yep. Incredible.
In other animals, the food pipe leads directly from the mouth to the stomach.
Which makes sense, right? That's how ours works.
But in the leatherback, it takes a circuitous course around the stomach.
And it's not even, it's more dramatic than this. As I understand it, it actually goes past some of the intestines down near the pelvis almost, and then loops back around.
Making it 6 times
I think this is underselling it.
Longer than other sea turtles.
Yeah, nuts. And there's Jeanette right there. Dr. Jeanette Weineken will hopefully be streaming with her in Florida. And one of her students, Dr. Justin Peralt, who I think he was one of her first students. He's got his PhD, and we're going to be having a special interview with him on Friday, all about leatherbacks. So anyway, yeah. Oh, I can't wait. It's going to be great. So that is unique for leatherbacks. All other sea turtles, I think their esophagus is pretty much like ours. It runs from the throat to the stomach. With leatherbacks, it still goes from the throat to the stomach, but it goes a much longer path down around the back of the stomach, and then it loops around to the front. Again, like this. But I think this might still be underselling it. I want to say it goes back further than that. What benefit does that elongated GI tract have? It helps them digest the jellies, and it helps them take a huge number of them in at a time. Here, I think they might talk about that.
It is already looking phenomenally long. It's funny, isn't it? It doesn't matter how many times you do this, it never ceases to amaze me how many miles of digestive system there are inside an animal. We've got the whole of the digestive system now out on the table.
So in the esophagus, you've got those papillae.
The esophagus, or the food.
So it's not just in the mouth. Those spiky, spiny papillae, not teeth, but papillae, they're soft tissue, but they're still pointy and like keratinized. It goes all the way down the esophagus. So that's what, like 10, 15 feet long, something like that?
Pipe going from the mouth down to the stomach. And I tell you, if I showed a photograph of that to 20 of my mates who are vets and said, what is that? They would never in a million years say it was the inside of an esophagus. It is the weirdest thing I have ever seen inside an animal.
It's totally sea turtle.
And they go from really quite small here up near the mouth, and as you get kind of 2 feet in here, they are absolutely colossal. I mean, look at that. It's like a finger, very pointy, and then down at the base of it, there's loads more. And it's incredibly thick, the wall.
Yes, and keep in mind, many of them are feeding in cold areas, and so you actually see the muscular wall and then this insulating.
It helps protect them from the cold, because they're taking in all this seawater with the jellies, and the jellies themselves are going to be really cold too. You don't want to make the rest of your body cold, so it's kind of like a thermos or something. You're containing the cold inside your esophagus, and you're not letting the cold sap your body of its heat.
Fat. So if these animals can insulate and not lose body heat as the food comes in, especially when they're bringing in cold water, they're saving energy.
It's an insulated food pipe.
It's an insulated food pipe.
It's so cool.
Yeah. I love this animation.
This long, spiky food pipe is the key to how this turtle can cope with its diet of jellyfish.
Yep.
For this giant, its feeding philosophy is quantity, not quality.
Yep. Not for the scoopers. Exactly, Jacob, right?
To prevent its stomach filling with seawater, the food pipe acts as a temporary storage vat.
Yep.
When it fills, muscles squeeze the water out, whilst the finger-like papillae keep the jellies in.
Does that make sense?
Before they're then passed into the stomach.
Incredibly weird and cool.
This unique adaptation allows the leatherback to eat its body weight in jellyfish in just one day.
Nuts, you know? What an incredible animal. Just bonkers. Jacob says, that's insane. I mean, these animals live on this planet today alongside us. We are so lucky to live at a time when these creatures are around, you know? These are our neighbors. And I mean that in a not entirely metaphorical way. I mean, I live here in the San Francisco Bay Area. There are leatherback turtles that have been spotted just out there past the Golden Gate Bridge, out in the Gulf of the Farallones. I'm hopefully going to be doing some field work with a leatherback crew in September down by Monterey. Chances are, wherever you are in the world, there's leatherback turtles not too far away because they are cosmopolitan in their distribution. So they live in pretty much all the world's oceans. They don't really like to go way up close to the poles. So you won't find them down near Antarctica or up. They don't get really deep into the Arctic Circle, but they have been, I think, within the Arctic Circle before. They've been documented there. They've been found around the Aleutian Islands of Alaska. But yeah, and if you want to, you can look on iNaturalist. And, Dermot Kelly's leatherback sea turtle. Let's look at some observations. Map. There we go. So here's just where iNaturalist users have logged leatherbacks, where they've seen them. Chances are, wherever you are in the world, if you're not too far from the coastline, if you're not watching from central Russia, chances are there's a leatherback turtle that's been spotted. Maybe only a few hundred miles from you. Yeah. Pretty cool. Here's an unusual cluster. Way out in the middle of the Atlantic. This one, I guess, got hooked on a line or something. Oof. Hopefully it was safely released. Oh, man. Yeah. Huge animals, you know?
A moment from prehistoric time.
And, if it can't scuba, hey, thank you for the follow. Welcome to Paleontologizing. I know that is a dream of some scuba divers that I've talked to see a leatherback in the wild. They're, it's a sort of creature that you're extraordinarily lucky if you get to see one, because they are not common. Their populations have declined by something like 95, maybe 99% over the past few decades. They are endangered. They are at severe risk of extinction. And I consider it a tremendous privilege to be able to, to live at the same time as these incredible animals, date all the way back to the Cretaceous period, to the age of the dinosaurs, but also to be starting to get involved with leatherback research and conservation. That's why I'm going to Florida next week. So, anywho, if you want to take a look at that map yourself, here's a link on iNaturalist, which I cannot recommend this app enough. iNaturalist is such a cool thing. Here, while we're talking about it, actually. I've heard people describe it as like Pokemon Go, except it's actually real. Let's see, trying to find you a decent video intro to iNaturalist. This is scheduled for Friday. That's cool. Yeah, we'll do this. This is a good one. We watched this before, but it's
My name is Sam Kieschnick. As a little kiddo, they called me Sam the Bug Man. Look at that. Isn't that a beautiful spider? Just beautiful. I am an urban wildlife biologist. So I work with people. I work with the people that interact with nature. We've got a bunch of them, a bunch of different species here. This one's a really interesting one. Look at this. Yeah, this is one that you got to get a picture of. How's your camera skills with your cell phone? Sweet, sweet. Sweet, but that's all right. This is an interesting one. Whoa, that's actually a really cool catch. Look at that, the black saddlebags. Gonna be perfect in your collection. I am bonkers about this tool. I'm bonkers about iNaturalist. For me, I get so much personal enjoyment out of it. And I've been using it every time I go outside. I have over 100,000 observations. I've been using this tool for a little while.
I've got just shy of 600 at this point. If we go to me here, yeah, there we go. Observations. I've got how many? 596. And some of these I'm really proud of. Like, this is probably the only northern gannet in the Pacific Ocean. I saw this on a special trip to the Farallon Islands, and his nickname is Morris. People know about him. But all the rest of his species live in the Atlantic. He's the only one in the Pacific. Who knows how he got there, but he seems to be the only one. And Deathsaurus says, my only concern with this app is privacy. Well, that's the really cool thing, is that you can obscure the location. And I think you might even be able to adjust that in the settings so that, like, if you're worried about doxing yourself or something, you don't have to worry, because it'll just show, like, in a wide area. Like, okay, it was within this several miles or something this observation was made. So yeah. Wouldn't that also mess up the data? No, because researchers, if they really want to be able to use your data point for a study, they can do that. But, like, nobody else using iNaturalist would be able to get into that, as I understand it. Yeah. Anyway.
I've identified about 600,000 observations for other folks around the world. So I just have so much fun using this tool daily. It's a database. It's a social network. It's kind of a way of life. I'll see an organism, I'll pop out my phone, I'll get out my camera, I'll take a picture of that organism, whatever it might be. And then I'll click on the what did I see, view suggestions. Yep. And this part is just mind-blowing to me. It compares it to millions of other pictures. And it gives me a suggestion of the common name prairie tea, or Croton monathogynous. I'm gonna select it, I'll save it, and now I'll upload it. And this is what happens. Look at science. Science is happening right now.
So researchers will actually use these data in studies on occasion too. And like people who are concerned with, say, leatherback turtle conservation, they'll keep an eye on leatherbacks. You can get notified of this sort of thing on iNaturalist. Oh, somebody saw one here, they saw one there. You can keep track of where they've been spotted, and it can help you gain a better sense for how the species is doing in a given area. Really, really important, cool stuff, and I love using iNaturalist. It's just phenomenal. And here's a link to that video right there. Yeah. You have a millipede on your ceiling, Wombat Hole? Really? Not a centipede? Centipedes are usually much better at climbing than millipedes are. Anywho, we'll be talking more about leatherback turtle. Oh, the keels on the back. So those provide a structure to the shell. Given that they have soft, semi-flexible shells, they don't have a hard shell like all other turtles. Their skeleton looks like this. Those are their ribs. Unlike every other turtle on the planet, leatherbacks don't have a hard shell.
Paleontologist version of heaven.
And Kai Jusamurai, thank you for the follow. Welcome to Paleontologist. It's good to have you here. Here's a leatherback skeleton with the leathery part of the shell, like, preserved in this skeletal mount. So they do have bony ossicles, but it's almost like a mosaic tile. They have hundreds of these little, almost like bony coins that make up the carapace, and part of the plastron too, I think. And carapace is the back, plastron is the chest plate. So other species of sea turtle, like this, I think green sea turtle right here, they still have like a bony shell. And then they have keratinous osteoderms that go over the top of it. Leatherbacks don't have that. It just looks like this underneath. But they've got those coin-like bony osteoderms that they kind of interlock. It is like a mosaic tile, but the whole thing is flexible, so it can compress at depth, so that the shell itself squishes rather than cracking when they dive really deep. And then the keels that they have over the surface, like you see here, these give a little bit of structure to that shell, and they also are nice and streamlined. Kind of reminds me of like a football or something. So they just cruise through the water with minimal water resistance. It really is a marvel of evolution. Just extraordinary. What a cool critter, you know? For a better spiral, there you go. Except they don't want to have any roll as they're moving, so the keels kind of prevent them from spiraling. Yeah. And Cacklin's Surf, I'll see you around. Thanks for being there. Yeah. And H Sweet, how are you doing? Anywho, with that, we've got some fossil news to cover, I believe. Not I believe, I know we do. We've got some really cool stories to cover today. So let's get into this. It's taken me a while to get here. But, well, let's start up the fossil news right now. There we go. Okay, let's find the music button. Our first story today concerns Alvarezsaurs. This is one of my favorite groups of dinosaurs because, well, I was on the team that helped discover and name a new one of these guys out in Montana. Really cool, weird group of dinosaurs. Long, stilty legs, really short, can't quite say stubby arms. The arms are very short, but they're very, very, very strong. Extraordinarily robust arms on these guys. But the question is, like, what and why? What? Why have these long, stilty legs like this, but extraordinarily short arms, with one big claw on each hand? Why? What do they do for a living? Asked Mint Julep. We have a new paper about that today. But before we get to that, let me show you a quick clip. There we go. To help explain this. So this is Mononychus here, as portrayed in Prehistoric Planet. So yeah, so they're generally less than 2 meters long, Alvarezsaurs. They're pretty small little dinosaurs. I think we might actually have preserved hyoid bones in the throat that do suggest a long tongue for these animals. But the barn owl thing here is speculative with the big facial discs, but barn owls do use those to funnel sound into their ears to hear. Maybe these guys did the same thing. There we go. Charlie's Dragon says, I'm not convinced it was for digging for termites or ants. It would have almost lie on top of the nest or log to dig. I mean, it is a puzzle. Like, what a weird body shape. No other animal on the planet today looks like this. Extremely short, but extremely powerful arms with one big claw on each hand. Like, what are you doing, you know? What's the deal with that? This new paper, I'm excited to read, deals with that. And what about the feathers? So pretty much everybody else in this part of the dinosaur family tree has feathers. And for Shuvuia, which is a little Alvarezsaur from Mongolia, we do have evidence of feathers. So yeah, most of these guys not very big. Shuvuia is there in the blue. It may or may not be fully grown. But, yeah. Feathers. Specimen IGM 100/977 of Shuvuia is found surrounded by small, hollow, tube-like structures resembling the rachis of modern bird feathers. Though highly deteriorated and poorly preserved, biochemical analyses later show that these structures contain decay products of the protein beta-keratin, and more significantly, the absence of alpha-keratin. Only bird feathers completely lack alpha-keratin. These findings show that, though poorly preserved, Shuvuia likely possessed a coat of feathers, which makes perfect sense. Alvarezsaurs as a group, they're either near the Ornithomimosaurs, the ostrich dinosaurs, or they're actually within Maniraptora, closer to birds. I don't know what the current consensus is on these guys. Classification. Yeah, so they might be near Ornithomimosauria. Or they might be Maniraptorans. But yeah, really cool critters. So yeah, pretty neat. Let's get into the paper. The title is Range of Motion and Myology. Myology is study of muscles. Supported digging function for the forelimbs of the Alvarezsauroid dinosaurs. This is in Proc B, as we call it, the Proceedings of the Royal Society Publishing B. Proc B is a fairly prestigious journal, I guess. And I recognize some of these. Author Xu Xing is one of the most famous paleontologists in the world. He may have found or named more new dinosaurs than anybody else alive. He's kind of China's superstar dinosaur paleontologist. Emily Rayfield is a past president of the Society of Vertebrate Paleontology, and she works on a lot of like digital modeling, a lot of FEA, finite element analysis, stuff like that. So I'm sure she had a lot to contribute to this paper too. Cool stuff. Here's a link. And it then says fast runners don't dig. I'm sure we can come up with exceptions to that rule. Burrowing owls are probably fairly fast runners. Road runners might dig too. Deep hunting dogs will dig burrows. I don't think cheetahs dig burrows, but hyenas definitely do. They're not the fastest though. They have weird limb proportions. But there are lots and lots and lots of reptiles who are very fast runners and also dig. There's lots of species of lizards that are semi-fossorial, and they're very fast runners. So yeah. So you'd be surprised. Digging behavior doesn't get a lot of attention in animals. There's lots of animals who will actively dig burrows, and like hardly anybody in the general public knows it. Yeah. Meerkats. Yeah, that's a pretty good example. They're not cursorial or anything. They're not like super runny runners. They're pretty speedy. Yeah. So yeah. Anywho. And when we're talking about digging, we're not necessarily talking about digging a tunnel or something like that. We're talking more about maybe hook and pull digging. Denver Fowler talks about that, and we were hanging out with him at the Badlands Dinosaur Museum last year.
Yeah, let's see, it's like 3:10 right now, so we're like an hour and 10 minutes into the stream.
I walk around this exhibit a lot.
Yeah.
Our streams, but I don't know if we have many people across the streams.
Should we talk about, well, I don't know, do you want to talk about any of these smaller displays over here? Before we move on to the really cool stuff like Triorachunkus and claws and all that?
Well, I can just point to them and say, well,
yeah.
These are a lot of the older displays that we had when we came in, and I've started squashing them together and condensing them a bit. And this mammal material there, there's some quite nice mammal skulls, mostly from far away from the So
there we go.
Museum grade cast. I have to get so you.
Here's Triorachunkus here.
It's like you can see.
This is at the Badlands Dinosaur Museum in Dickinson, North Dakota.
It's a really good one. The name Triorachunkus means Captain Hook on account of those claws there. And prairiensis, because it was from the American Prairie Reserve. That's where Jack Wilson found the claw. This claw? Oh, man. Yeah. So that's a cast, right?
What?
The claw that you've got?
No.
That's the original.
This is the one.
That's the holotype.
We have in our collection.
Yeah.
Or paratype?
So this is the medium-sized one. I've shown the paper many, many times on stream. But look at that. Yeah. And at the time you said this might be one of the most complete ones in the world, given that it's got the tip at the end?
Yeah, this is the most complete one in the world.
Wow.
It's certainly the most
from this
complete
entire
one in
group.
North America. It's more complete than the ones from Mongolia.
Mm-hmm.
And what this shows is that the claw is very curved.
Mm-hmm.
Like people have said in the past that you've seen reconstructions, like you can see on this drawing here,
Mm-hmm.
it's got a quite blunt claw. Well, that was because the original Mononychus claws, the tip is broken,
Yeah.
and people didn't realize how curved they were.
Mm-hmm.
Actually, one of the things that we did a lot of research on claws, and you can see that you can reconstruct the curvature of the claw by modeling a couple of circles on there. But that's relatively recently that people have been doing that.
Lenina says, how long would that have been with the keratin? It's got a pretty big, nutrient groove on it. It would be maybe 50% longer in life with the keratinous sheath over the top. Denver talks about that a little bit here.
We started doing it. But this specimen, the little tip, it was broken, but it was right there next to it, and we can see how complete it is.
Just incredible, yeah.
And what's that line in the middle, asks One Fun Panda? It's called the nutrient groove, or the blood groove. which, let me see if I can find you a clip. Where's that museum? Gosh darn it. What's the name of that town in Utah where the dinosaur museum is? It's just called the Dinosaur Museum in Blanding. There we go. So at this museum, they've got a really cool display with a... There it is there. Yeah. Excellent.
Their claws, but that doesn't show you how big the actual claw would be in life. That's really neat. I love that.
So that is the nutrient groove. This is the bony part of the claw. And then in life, it's covered by a soft tissue. It's not really soft, but that's just what we call it because it's not bone. If something's not bone or tooth enamel, we call it soft tissue in paleontology, including keratin like this.
I think this maps out to like how big the claw should be with the keratin sheath over the top. Really neat. Yeah.
So that groove that runs down the claw
often is much larger than the size of the actual bone.
That groove that runs through it is nutrient supply. So that's supply of blood and other nutrients that go to sustain the keratin. The keratin is like the same material as your fingernails, but your fingernails still need blood. They need nutrients going to them so they can continue to grow. It's the same with this. So by studying the size of that groove and, I guess more importantly, the morphology of the claw, the length and the curve, you can model how long the claw would be in life with the keratin sheath.
I think this maps out to like how big the claw should be with the keratin sheath over the top. Really neat. Yeah. The sheath can be and often is much larger than the size of the actual bone.
Yep.
Yeah.
What do they say about Suchomimus tails? Were they similar?
Anywho, here's a link to that VOD there. Cool. So Denver talks about that here too.
So yeah, so this is the most complete Alvarezsaurid claw. There are other ones that are supposed to be complete, but the tips are often still a little bit damaged.
So nobody realized how pointy they would get until you
and how curved they are.
Yeah. Yeah.
So yeah, this is I think leverage is more. It's very curved, so you can hook and pull rather than digging with it. Sort of, it's more hook and pull destruction.
Mm-hmm. So that's that key point: hook and pull destruction. Hook and pull, which makes sense for an animal with such short forelimbs. They're so short, but they're so thick and strong that might make a lot of sense. Maybe they're using their whole body as leverage, where they're kind of using their hips as like a pivot point, like a fulcrum, where they can hook in with their claws and then tilt their whole torso up. Let's see what they say in the paper, though. And it just published today. Range of motion and myology, that's muscles, support a digging function for the forelimbs of Alvarezsauroid dinosaurs. Here's a link to this paper. It is open access. There we go. PDF.
Access granted.
Beautiful. And yeah, much too short for climbing, bad fraginator. Yeah. So let's look at the abstract first. Oh, and before, let me just say, I think it's often really important to show people the original scientific literature here on Twitch. This is how we as scientists communicate ideas to one another. This is the currency of science here, is publications. Publishing scientific papers. There has been probably years worth of work that went into this publication right here. When we want to be able to present our science to the world, This is how we do it. But we as scientists often don't do a very good job of presenting it to the world afterward. We publish these papers in scientific journals. They're read by other scientists. But generally, this information doesn't make it out into the general public unless maybe it shows up in a popular book or a documentary, or maybe we talk about it on the news or something if we're really lucky and these people are excited about this. Or maybe a science communicator takes this and presents it to folks in a way that's understandable. That's what I'm trying to do here. But I also think it's important to show you the actual scientific paper as well, you know? So I'm going to do my best to translate this for you like we do here on Paleontologizing. If you have any questions, don't be hesitant. And, yeah, we'll get into it. But here it is, straight from the science horse's mouth. So let's look at the abstract first. This is a short summary of the paper right at the beginning. And even if it's a paywalled journal, you should still hopefully be able to read the abstract on the page. So let's say that this was not open access. Let's say that we had
access denied.
It's paywalled. You could still read the abstract on the page, and most of the time when we as scientists are reading papers, like, mostly we just read the abstract, unless we're really interested in it. But I am very interested in this paper. Let's take a look. So it starts, numerous lineages of theropod dinosaurs. These are the two-legged, mostly meat-eating dinosaurs, the group that birds evolved from. Numerous lineages of these dinosaurs display notable modification of the forelimb. They do a lot of weird, interesting things with their arms. Particularly, reduction in size and number of digits. So a lot of two-legged meat-eating dinosaurs, like T-Rex, for instance, really short arms. And Tyrannosaurus only has 2 arms per hand. 2 fingers per hand, excuse me. This is an ongoing trend. We see this in lots of dinosaurs. Dinosaurs, when they first evolved, they start off with 5 fingers, just like us. But then over time, they tend to lose those. And actually, they do it back to front. So you lose the pinky first, then the ring finger. And then with Alvarezsaurs, some of them might only have the thumb left. That's the thumb on this guy. You're looking at the thumb right there. Anyway, Alvarezsauroids, these dinosaurs, are one of the most striking examples of this, exhibiting extreme shortening and increased robusticity. So they're making their arms shorter, but so much stronger, thicker, more powerful. With a functionally monodactylous manus. So for all the intents and purposes that matter, they only have 1 finger left, just their thumb. These features are generally interpreted as adaptations for digging, possibly as part of the Myrmecophagus ecology. So there's a general consensus that's emerged, like when we as paleontologists talk about these critters, we usually say, yeah, they're probably digging with these. But what does that mean? And how do you dig with a hand like that? Myrmecophagus means eating ants or termites or similar insects. So here we test this hypothesis. Again, science is not just about coming up with nice stories that sound plausible. That's not science. Science is about testing ideas. Following the information where it leads, looking for evidence, running experiments, gathering data, testing things. So here we test this hypothesis using computational range of motion analysis. So they're going to be looking at these limbs, digitizing them, putting them in the computer, and seeing how much flexibility they really have at the joints. How much can they really, what is their real range of motion, you know? Looking at the shoulder and elbow joints to demonstrate the feasibility of digging behaviors in Mononychus olecranus, a highly specialized Alvarezsauroid. This is Mononychus here. And the less specialized Benichus ulatensis. So they're looking at one of these guys that's later on, like, highly specialized. It is one of the most Alvarezsauri of all the Alvarezsaurs, you know? They took the Alvarezsaur dial and turned it up to 11 for this guy. For Benichus, is it Benichus or Benichus? Yeah, here's an earlier one, and it's not nearly as specialized. So it's got short arms that are pretty thick, but they're still got 3 functional fingers. It's not quite there yet. This guy's also earlier in time. Benicus is from the Bayan-Gobi Formation, which is what age? Early Cretaceous. Albion, early Cretaceous. Okay. So we go back to the Cretaceous period. Your dinosaurs, except for a few species of bird, go extinct 66 million years ago. Mononicus, this critter, very derived, advanced, specialized. It's from either the Maastrichtian or the Campanian, somewhere in here, I think. Benicus is from the Albion. It's much earlier. It's like 30 million years earlier, give or take. So they looked at both of these animals, and hopefully by looking at both, they can see what are the trends in evolution, what's happening over 30 million years, and like what direction is this trend going in? As the arms continue to specialize, what are they adapting for, you know? Does that make sense? We found that Benicus had the capacity for various digging styles and generalized forelimb function, so their arms, they can kind of do a lot with them. While Mononicus, our later guy with the much more specialized forelimbs, has much more restricted motion and may have employed a highly specialized digging style. We also identify similarities in forelimb muscle movement arms between Alvarezsaurs and specialized mammalian diggers. I bet you they looked at aardvarks, maybe armadillos, maybe anteaters. This supports adaptations for digging. So they're saying what they're seeing points toward digging ability for these animals. These findings are consistent with interpretations of insectivory in Alvarezsauroids, so it supports the idea that they ate bugs, and suggests increasing specialization to myrmecophagy, eating ants and or termites, throughout their evolutionary history, shedding new light on the evolution of this enigmatic clade and the ecological diversity of non-avian theropod dinosaurs. Cool. Really neat. Deathsaurus says, are 2 specimens really enough to test this? You'll see. The answer is yes. We often don't have many specimens when we're dealing with dinosaurs because we don't have a whole lot of information. But you'll see how this works. Here we go. Background information. There's 3 different dinosaurs here. They're looking at the shape of the forelimbs, how the bones line up, their proportions, and everything else. That's crazy that Mononicus there. Incredibly weird proportions on this animal. That's the forelimb. So your shoulder blade, coracoid. There is the humerus. There's the radius and the ulna. The ulna is twice as long as the humerus. Excuse me, twice as long as the radius. So these are the bones that we have here in our forelimb, in our forearm. Radius and ulna. So our ulna is maybe a little bit longer than our radius. But they're roughly the same length in a person, you know? Radius and ulna. And Mononicus, the ulna is like twice as long as the radius. And they have a huge olecranon process. This is the elbow. Animals that have a big olecranon process like this are usually diggers. Armadillos have this. Anteaters have this. Aardvarks have this. So here's a 9-banded armadillo. Look at the olecranon process. Look how long that elbow is. Enormous. same thing in these guys. So this is something we've known about for decades. That's not what this paper is about. This paper is trying to take these general observations like this and actually put some numbers on it. So like, let's digitize some of this stuff, let's run some tests, you know? So that's what they did here. I love this little figure that they put together. So, reconstruction of muscle attachment sites. So by looking carefully at these bones, looking for rough patches on them, you can figure out which areas the muscles would have attached to, and then you can infer how large and how long, how voluminous those muscles are. So they did some 3D modeling here. Come up with movement arm measurement and principal components analysis there. There we go. And then range of motion simulation too. So what could they actually do with their arms based on how they're built, the bones, and then the muscles on top? What kind of motions are they capable of, you know? Yeah. So yeah, they just go over this in the text here. A lot of this stuff would probably benefit from, like, video. Maybe there will be a press release for this in a few days. But for right now, we've got to deal with these still images. Yeah, protraction, depression, rotation. The range of motion for these things. Flexion and adduction. Cool. So there are people who, like, this is most of what they do in paleontology, you know? Is looking at how these creatures move. And John Hutchinson is somebody who does this. And I'll let him explain a little bit of that. This is a talk that he gave at the Burke Museum in Seattle.
Supporting itself on one leg, like it's running, so supporting itself on...
Here we go.
Science fiction monsters or dinosaurs, to me, Godzilla was just as real as T-Rex. So I was really excited about big things in general. King Ghidorah over there, the three-headed monster, was one of my favorites.
Hey, Daily Dash, how you doing? Welcome, welcome.
And I think that fascination in giant things, real and not real, just continued and explains why I now study them as a scientist, including all kinds of weird things interest me, like fanciful things that could never work. And it's interesting to think why they couldn't work. And that really, when I first learned as a kid that a giant Godzilla just could not work in terms of the physics of movement, it really bummed me out. I was sad that Godzilla could not really exist because it was too big to walk, but it also made a lot of sense to me. So the scientist in my mind began working when I realized that and thought, oh, actually, even though that's sad that Godzilla could not work as a real thing.
So to be clear, John Hutchinson is not one of the authors on this paper, but this is kind of his wheelhouse. I would not be surprised, actually.
I'll be talking about.
I wouldn't be surprised if he's one of the reviewers on the paper.
Today is perch.
Anyhow.
It's a very thin coating of snow that shuts. And a bit about what we do, but yeah, today I'm going to really focus in on the problem of size as applied to dinosaurs. And if you want to talk to me more about this research after the talk, I'm always on social media, on Twitter, and I have a blog and so forth. It's easy to find me on the internet. I'm all over the place.
Anywho, but yeah, reconstructing the musculature and the volume of different things.
I could at least walk slowly. So our model accounted for that by getting rid of postures in which the required size of muscles and other things would be too large in order for a T-Rex to actually support one body weight on a leg at a time. So that little bit of yellow space, that kind of a crouched animation, even though it was useful in showing to the public, here's roughly what we think a T-Rex moved like. So, why did it do that? I don't know. Okay.
Yeah, this is important.
That's interesting. So we came up with a new approach inspired by making that animation.
And holy cow.
Because we study fossils, especially dinosaurs, we capture the imagination of children. Yep. And that makes vertebrate paleontology a gateway for
Draw
all
Curiosity
science.
and their 29 children are walking through that gateway right now.
Draw Curiosity, how was your stream? I hope it was really good. Welcome to Paleontologizing. Dr. Ines, excellent stuff. It's lovely to see. Thanks for rating in. I really appreciate it. We are talking about biomechanics right now, and how we can reconstruct that for extinct critters like dinosaurs. Brand new papers just come out about one of my favorite groups of dinosaurs, the Alvarezsaurs. These guys, and so you've come in at an excellent time. Yeah, Ines, thank you for the raid. Again, I hope you're doing really well. I hope your subathon recently was a grand success. Thanks for bringing everybody over. Here, for anybody who might be new to the channel, anybody who just popped in and they're like, what in the world is this? Paleontology on Twitch? Play a quick little welcome video for you. Channel trailer to introduce you to what we're all about here.
My name is Danny Anduza. I'm a dinosaur paleontologist, and this is Paleontologizing. Ines says, my voice is still not quite recovered from the subathon, so we did some technology and art, and I figured it would be wise to end a bit earlier. Yeah, you take care of yourself, Draw Curiosity. Thank you for rating in. Welcome, everybody. I appreciate it. Thank you, Ines. Science isn't just test tubes and beakers and white lab coats. What we're doing out here is science, too. We're testing hypotheses by excavating these fossils.
Join me for museum tours, interviews with other paleontologists, audience Q&A, 3D printing. It's pretty big. Who thought this was a good idea? And of course, live dinosaur digs.
A limb bone from a new duck-billed dinosaur.
I invite you to tune in and experience the adventure of fossil science. Yeah, welcome, everybody. And addicted to capping, rotating their feet to the center. So dinosaurs didn't really rotate their feet. There is a group of modern reptiles that walks in much the same way, almost entirely the same way that dinosaurs did. And we call those,
dinosaur.
Oh. Sorry, we call them... Birds. So if you look at, say, an emu walking, an emu is a dinosaur. This is very close to the same gait that a dinosaur like Allosaurus or Velociraptor or T-Rex would have had. Birds are just a little bit different in the sense that they don't move their thighs a whole lot, whereas dinosaurs would have. But, yeah. Birds don't really have big muscular tails anymore, like their dinosaur ancestors did. So they do walk a little bit differently, but where they place their feet as they're walking and all of that is going to be the same. It just more has to do with the thighs. Big difference. Yeah. Kind of an L for the birds, says Draw Curiosity. I mean, yeah. What's interesting is that, like, that pressure for them to reduce their tail seems to have been a widespread kind of pressure, because there's several different groups of bird, and even a few different dinosaur groups, that independently reduced their tails down. So, modern birds have what we call a pygostyle, or sometimes referred to as a parson's nose. But their tail has some vertebrae at the end that all fuse together. So that's a particularly weird one in a bird. PYG, that means pygostyle. Yeah, there it is on a chicken. Maybe that's a pigeon. Like this. But the pygostyle is those shortened and condensed and fused vertebrae at the end of the tail. Several groups of dinosaurs, including several groups of birds, did that independently of one another. They all independently evolved that. So there was something going on there.
Ferocious killer, Tyrannosaurus Rex.
Vilsira, thank you for the follow. Welcome, welcome. It's not Ingenia, it's Nomingia. Yeah, this is an Oviraptorosaur dinosaur who was reducing its tail as well. And you've got a bit of a pygostyle going on at the end. It probably supported a big fan of tail feathers like this. So it was probably a display thing. Really interesting. Yeah. I would think that a long tail would help with stabilization when flying, says Ines. Some birds do have long tails, but they don't tend to be for stabilization. They're usually for display. When you look at something like a Eurasian magpie, or a North American magpie for that matter, they've got a long tail, but I don't think it's really for stabilization purposes. I think it's mostly for display. The earliest birds that we have fossils of, critters like Archaeopteryx, they had long bony tails. And I guess this worked for them at the time, but later birds, they shortened their tails up. And that might be a weight-saving measure. It might also just be something to do with, like, gestational time. So, like, if you can cut some corners, well, you're developing as an embryo. Doing things like, hey, I'm not going to take the time to grow a long tail or grow teeth in my mouth. I'm going to skip those steps, and I'm going to hatch a week earlier. So that means there's one less week that I'm sitting helpless inside of an egg. Maybe it increases your chances of survival that much or something, you know? These are ideas that we have, but they're difficult to test, you know? You gotta be careful that you're not just telling a just so story. But yeah. Anyhow. Yeah. But with that said, let's get back to our paper, because this is trying to actually test some of these ideas about these animals. And they're really weird, incredibly short forelimbs that are super robust. What in the world are these guys doing?
What?
What's the deal with them? What is that about? We were watching a quick clip of John Hutchinson talking about this. Talking about his work on
Instead
dinosaur
of just
biomechanics.
showing how T-Rex moved, which is an easy way to approach the problem, although for us it was unconvincing, we started with showing how T-Rex didn't move. So trying to start with all the ways T-Rex might have moved,
like this flouncy
maybe,
gait.
and get rid of the ones that just wouldn't work.
Yeah, that doesn't work.
So this approach just applied the rules of how animals work to try to say, well, is that fairly upright way of moving of a T-Rex? Is that possible or impossible? Is that really straight-legged way of moving in a T-Rex? Is that possible or impossible? Or is that really crouched way of moving, possible or impossible? We used an approach, as I'll show you, to try to figure that out, get rid of things that were impossible or implausible. So we started with a simple leg posed in the middle of a step like this. So it's just supporting a T-Rex supporting itself on one leg like it's running, so supporting itself on one leg at a time. And it has a hip, a knee, and an ankle joint, each of which can rotate through 180 degrees. So that's
I'm showing you this just to kind of illustrate this is the sort of work that we as paleontologists do here.
Of movement.
This is not my specialty. I don't do biomechanical work, not really. But this is John Hutchinson's wheelhouse, and that also has to do with our paper here. But before we, where is that? There we go. I want to show you what he said about what his favorite dinosaur is. It's also mine. One of mine at least. Show transcript. There we go. What happened with the closed captions? Hang on a second. This is so annoying. I don't know what hotkey it is, but it changes the opacity or the... font opacity.
There we go. Finish up. First of all, classic question. What is your favorite dinosaur?
Well, I have to say T-Rex is one of them, but because I've worked on T-Rex and it's cool, I admit. But I also the only dinosaur I ever discovered was a little tiny bird-like dinosaur called an Alvarezsaur from the Hell Creek Formation of Montana. It was in a...
This is Triararchuncus he's talking about. This is the dinosaur for whom I am an author on that paper. Yeah, and John Hutchinson, kudos to him. He did not name it at the time, because at the time he had 2 fragmentary bones. He knew it was an Alvarezsaur, but he didn't want to name it based on such scrappy material. Later on, my crew found more material of this animal that's much more diagnostic, and we even had like a growth series, small, medium, and large adult. So we felt justified in naming it. Denver Fowler is lead author on that paper. And here it is. So yeah. Anywho, very cool that that's his favorite dinosaur.
And also, the only dinosaur I ever discovered was a little tiny bird-like dinosaur called an Alvarezsaur from the Hell Creek Formation of Montana. It was in a museum drawer at Berkeley, and I discovered a little bit of its hip bone, and the hip bones were so distinct I knew exactly what it was. And they're really cool animals. They're only about this big, with stubby little arms and long, long legs and a long tail, and they're feathered. Really cool things that people think maybe dug in anthills, because they have these big stubby arms and little tiny heads with very sharp needle-like teeth. I still don't know what they did. They're mysterious animals, but they're really, really cool. And the fact that I found a piece of one that I didn't get to name, but at least it's some sort of new animal from Montana. That makes it one of my favorite dinosaurs. Cool.
Yeah. Here's a link to this talk, and there's a timestamp there. There you go. Got the spinning pie. Tail out of my face. And that's a copy link. Paste. Why is this not working? There we go. Goodness. So we'll get back to Alvarezsaurs in a second, but first I've got like 4 questions in the chat that are unrelated. Hang on. We'll try and get to these. Oh, Patrick Pirate, it is one of the best questions to ask adults. Here. What's your favorite dinosaur? Where is this from Kerry Woodruff? There we go. You know, a person's favorite dinosaur says a lot about them. We did a whole stream about this a few weeks ago. Let me find that VOD. Oh, goodness, Mini Pie, stop. But there was a really interesting YouGov survey that came out about people's favorite dinosaurs. And, where was that? There we go. Anyway, here's a link. There you go. Yeah, and you can still say Brontosaurus. I mean, that's the thing. That's kind of what Kerry Woodruff was saying there. He says, although asking if someone thinks Brontosaurus was a real dinosaur is really a better first date question, and it is a real dinosaur. It's just, should we use that name to cover, like, to describe it? Uh-oh, wait. Hey, you be careful over there. This is not a jungle gym. Oh, goodness. You be careful, okay? But yeah, whether or not Brontosaurus and Apatosaurus are the same dinosaur is still being debated. Quite a few sauropod folks who remain healthily unconvinced that Brontosaurus should be the valid name. Yeah. But ultimately, whether or not Brontosaurus is real, that's the wrong question. It's a real animal, obviously, but is it just the same thing as Apatosaurus? That's what the question is. Should we use that name Brontosaurus? Or should we use the name Apatosaurus, which came first? The question is, are these two different dinosaurs, or is it the same thing? If it's the same thing, we need to call it Apatosaurus. But if it's different, then you get to use the name Brontosaurus for the ones that are different. Does that make sense? Yeah. Anywho, Daily Dasps has a question. What are some key differences between evolution and creationism? Main differences: evolution is science. We make testable predictions. We test those using data. We make observations of the natural world. We watch evolution take place in the laboratory and in the fossil record. Evolution is science and creationism is religion. That's really the primary difference. With creationism, you start with your conclusion that a deity supernaturally created all living things, usually in a very short time span. And then maybe you try and cherry pick some loose bits of information to try and support that. But that's the thing with creationism, is you're starting with your conclusion and working backward. It's the opposite of science. With science, when we're studying evolution, we start off by gathering information and running experiments and, obtaining data and all of that. And then we let the evidence lead us, We follow it wherever it goes. That's the primary difference. But if you want an excellent resource on this, I can recommend a gripping documentary to you, Daily Desk. Here we go. From PBS Nova, really good stuff. And again, the copy and paste is not working for whatever reason. There's a timestamp in it. It doesn't matter. Here we go. Here's a quick trailer.
Over.
I believe there is an intelligent design. In the beginning, God created.
Saying that you don't believe in evolution is almost saying we don't believe that the Civil War ever took place in the United States.
An extraordinary court case ignites a small town.
There's like a civil war within the community, there's no question.
And put science itself on trial.
Very important things were at stake. One is the future of science education in this country.
Nova reveals the story behind the headlines.
Anywhere you turned, we were getting attacked.
Witnesses started dropping like flies.
And probes the question, is intelligent design a scientific alternative to evolution?
Spoiler alert, it's not.
Of a science class.
Or religion in disguise?
It's a violation of everything we mean and everything we understand by science.
Judgment Day, intelligent design on trial on Nova.
Good stuff. That's one of the best resources that I can recommend to you because it's interesting, it's fun to watch, and I think a lot of the questions you might have daily to ask me, you'll find info there. Anyway, continuing to scroll down, want to catch up so we can get back to this paper. Let's see. Yeah. Anyhow, maybe this September, on the anniversary of the Kitzmiller versus Dover trial, maybe we'll have a series of special streams about that, because we've done that before. And, do I have any of those VODs? Are those up here? Kitzmiller. No. That must have been before we started saving VODs to YouTube. Anyhow. Yeah. Anyhow, yeah. Back to Alvarezsaurs, these guys. Speaking to this idea of science being about testing notions. You know, not just starting with a conclusion and going, well, I like this idea, so it must be like this. Like, no, science is about testing ideas. How in the world did these guys use their forelimbs? What are they for? What's going on with this? This paper is all about testing these ideas. Could they really be used for digging? What's the range of motion on these things, you know? So they did range of motion analysis on this. A lot of this stuff is going to sail over my head because I don't really do biomechanical work like this. But they're looking at protraction, depression, rotation of these different limb elements. Saying, like, how could they actually move? And then they're simulating the volume and arrangement of these muscles. Results. There's some of their data there. So these guys plot pretty well inside of a lot of the other digging animals that they looked at here. On digging animals too. The range of motion analysis presented here supports the feasibility of digging behaviors in both taxa, in Bentonychus and in Mononychus. Relatively larger forelimbs of Bentonychus likely granted it a wider functional repertoire than later branching highly derived paravercursorides. And Mononychus, however, that's in this guy. The highly modified morphology of the forelimb appears to have resulted in the reduction of the range of motion at the shoulder and elbow joints. So these guys, as you might imagine, don't have very flexible arms. Who'd have thought? Elevation and depression of the humerus are lessened, as are extension and flexion of the elbow, indicating that the forelimb function may have been more specialized. However, both joints still possess adequate mobility to engage in forelimb digging motions. Mobility at the shoulder of Mononychus is characterized by an emphasis on humeral retraction and long axis rotation. The motion at the elbow appears to have been mostly constrained on the extension slash flexion axis, but with potentially significant capacity for adduction. These movements also characterize the digging styles of extant humeral rotation diggers like the echidna, supporting interpretations of a similar digging style in Mononicus to these animals. Humeral rotation digging. So rotating your humerus in order to dig. I kind of want to find footage of that now. How does an echidna dig? Let's see. There we go. We might not be able to see past the spines and everything here. Oops, I gotta throw these treats away before Sweetie Pie finds them. Darn it. Yeah, we can't really see what's going on with the humeri there. A land urchin, there you go, airspace. But presumably they're doing something interesting with their upper arm bones, their humeri. I actually don't know how you'd find footage of that unless... Oh, maybe here? It's a short-beaked echidna, so different species, not quite as spiny as the last one. Get to see some digging? What's interesting, though, is that this is a quadrupedal animal, so they have to walk on their arms, too. Alvarezsaurs did not do that. They've got long, stilty legs, hind legs. They don't use their arms for walking, like these guys do. And so the idea that there's any similarity there at all is kind of fascinating. Snuffling around with the nose. Let's see some digging. Use those arms. Oh! Gosh darn it. Oh well. Yeah. Need lab footage? I guess so, Clarebird. Let me catch up to the chat here real quick. Oh, hello, Sweetie Pie. What's going on? Want to hang out here? Okay. Okay, that's fair. Yeah. He's like, I saw Sweetie Pie, I saw Mini Pie over here earlier, and this is where the cool cats are hanging out. Red time. I can't give her treats anymore. She might be allergic. We're trying to figure out what's causing these. What these scabs under here? Good scabs on your belly. Scabs on your belly. You had like sores on your ears, which are gone now. Those are cleared up, which is great. That's great. That's great. Yeah. Let's continue with the paper. The highly derived morphology of the elbow joint of Mononicus, with the single antebrachial condyle medially deflected and rotated, means that the arc of flexion and extension for the form is almost parallel to the midline, and the humerus is held out laterally. So, they're looking at how these limbs, how the bones in the forelimbs are actually arranged, reconstructing the muscles on it, figuring out the range of motion. I wish they had a figure here so I could... It's one thing to read it, it's a different thing to see it. And okay, that's it for the figures, I guess. I feel like with a paper like this, they really need somebody to animate this if they're going to do a press release, you know? if they want to really get this information out to the public, it's going to take some extra legwork. Arm work. You know? You gotta show and not tell. It's one thing to have a scientific paper where I can read this and take it in and be like, okay, this is not my area of expertise. I don't do biomechanics work like this, but this makes sense to me. I'll accept it. But if we want to communicate this to the general public, we got to get a little bit more visual, you know? So hopefully somebody figures this out, you know? We have some diagrams at least, or an animation would be really cool. Yeah. Anyway. Yeah. Huh. So anyway, cool stuff. I don't think there's any press releases about this yet, right? Hopefully they have something soon, because right now it's just the paper. And it seems like a really cool paper. But it, I don't know. I could try and keep quiet about this because I don't want to get scooped, but if somebody ends up doing this before me, great. I think there's one animal in particular. I don't think they mention it in the paper. We'll check. Cyclopes didactylus. No. There's one particular animal that I think might offer some interesting insight to what's going on with these weird forelimbs. And I would love to be able to do this project myself. Hopefully someday soon I'll be able to compare this dinosaur to a living animal. Cyclopes didactylus, or the silky anteater, who also have very short arms, with one big stupid claw on each one. These are insect-eating animals. And, I want to know exactly how similar their claws are, and the underlying bones. What's going on there, you know? That's not it there. It's a different kind of anteater. I don't think that's it either. Yeah. But this is a really cool critter. We don't have any of them in captivity in the U.S. I don't know if there's any in captivity anywhere in the world outside of Costa Rica, which is also native range. Oh, this is neat.
Imagine
New
an
video.
animal so strange, so delicate and so elusive that for centuries, even the scientists who studied it weren't sure it was real. Welcome to the world of the silky anteater, the softest, sneakiest, and perhaps the most magical creature you've never heard of. First things first, size matters, and this little adventurer is barely the size of your hand. At less than a pound, the silky anteater weighs less than a can of soda. And somehow, it still rules the treetops. But it's that fur, oh, that fur, that makes it a living legend.
Really?
Each
The
silky
claws for
hair
me.
is hollow, ultra fine, and packed so densely that raindrops practically bounce off. It's not just beautiful, it's armor. This tiny creature is wrapped in a shimmering, water-repellent cloak, tailor-made for rainforest life. Then there's the hardware.
There we go.
Two massive claws on each hand, curved like miniature scythes, strong enough to rip into termite mounds, yet delicate enough to climb the thinnest branches without falling. Rather like having Wolverine's claws. If Wolverine only weighed a few ounces and was exceedingly polite. Now, about their lifestyle, the silky anteater is nocturnal, waking only under the moonlight. But it's not just hiding. It's performing a masterclass in camouflage. Its fur reflects the golden hues of the night canopy, blending it perfectly.
Just ask this scientician. He'll tell you that in nature...
Gaming consultant, thank you for the follow. Welcome to Paleontologizing. It's good to have you here.
In forest's shimmering light. To a predator, the silky anteater is simply a whisper in the trees. Scientists have spent weeks in the field and spotted none, even when they know silky anteaters are there. They're the rainforest's little ghosts, the hide-and-seek champions of the animal kingdom.
I mean, kind of. I don't know. It's a lofty language here. Anyway, here's a link to that video. I'd love to get my hands on some silky anteater specimens and be able to compare them to Alvarezsaurs. Are their claws similar? Is their forelimb morphology similar? Sure, those guys, silky anteaters, use their forelimbs for locomotion, which these guys didn't. But do they have a similar kind of like hook and pull digging style, perhaps? You know? What information could we glean from a comparison there? Maybe one of these days, maybe in the near future, I'm hoping, inshallah, I'll be able to go down to Costa Rica and maybe work with nesting leatherback turtles there. And also look at some silky anteaters, you know? It'd be cool to do both things on a trip, get two birds stoned at once, so to speak. So we'll see. Yeah. Anywho, yeah. But cool new paper. Range of motion and myology supported digging function in the forelimb of Alvarezsauroid dinosaurs. This is neat. You love to see it. I'm glad to have been able to share it with you. We are kind of running out of time, though. I had 3 other papers that I was hoping to look at. One of these, the link isn't working for whatever reason. There we go. I don't have access to this journal, so star me here in the chat, or anybody else? We might have to look at this another time. But are we underfitting dinosaur growth models, accounting for intra- and interspecific variation? This is one of these things that I wonder about so often. And I'll see you later, Daily Dash. Thanks for being here. Yeah. When we're dealing with dinosaurs, non-avian dinosaurs from the Mesozoic era, we often don't have a lot of information. Some of you in the chat might be surprised to know that, like, the majority of dinosaurs that have been named if we look at hang on, what's going on with Wikipedia here? Hang on a second. What happened to... Whatever, I'll figure this out later. Oh, there it is. Okay. Why does Wikipedia look different? I don't like it. Here's a list of dinosaur genera. You'll see a lot of names here. Here's just the A's. These are genera of dinosaurs, so a genus might have more than one species in it. It's just the A's here. And here come the B's. Now, there have been something like a couple thousand different genera and species of dinosaur that have been named. The vast majority of these are known from just one specimen. Usually a pretty scrappy skeleton, sometimes just a handful of bones. There's a few dinosaurs that are only known from one bone. The point is, for the majority of dinosaurs that have been named, we don't have a whole lot of information. And so we don't have a good sense for how much they might vary on an individual level. Does this individual look different from that one because they're different species? Or can you just get a lot of variation within a species? Does that make sense? This is one of these long-running mysteries in dinosaur paleontology is, how do we tell the difference between critters that are dinosaurs that are different species, or ones that are, where they're members of the same species but just make them look different? Maybe the males and females look different. Or maybe the juveniles and the adults look way different from one another, because these animals are changing a lot as they grow and mature. This paper is about that. So, dinosaur growth models. How much do they change as they grow? This is really exciting stuff, and I'm really excited to read the paper, but I don't have access. Given that it is, I've published in this journal. The Journal of Cretaceous Research. I'm an author on this paper. Can you send me a copy of it? And they're like,
access denied.
No. You have to pay for it. I'm like, what do you... I'm an author on the paper. You won't send me a PDF? And they said, no. So anyhow, yeah. Top Trike says, why do people put blocks on published work? That's the publishing industry, you know? Scientific publishing. Don't get me started, but they make a lot of money selling a product that they themselves acquired for free. Yeah. Addicted to Capping says, what would you say is the ratio of dinosaurs that have been named to the ones that still never received the name? Capping, do you mean dinosaurs that have been discovered but haven't been named yet? Or do you mean out of all the dinosaurs that ever lived during the Mesozoic era? Because those are going to be two very different answers. There's probably at least a few hundred different dinosaurs that have already been discovered but just haven't been published yet. That's the majority of dinosaurs that I've worked on are ones that have been dug up and maybe even prepped and photographed and put into collections, but we just haven't gotten around to publishing on them yet because it's a ton of work. Shoot. The dinosaurs that I worked on. There's at least 10 or 15 different dinosaurs that I've worked on so far that are new species that we haven't published yet. If we have like between 1,000 and 2,000 different dinosaur genera that have been named, there's at least I'd say 5 times as many dinosaurs that lived during the Mesozoic, probably way, way, way more. It's funny because this is another project that I want to work on when I have time. But like estimating what is the number of dinosaur species that existed during the Mesozoic, and how many of them can we reasonably expect to find? These are tricky questions. Again, I was talking about this just the other day. It's kind of similar to the Drake equation in astronomy, astrobiology, trying to figure out, like, well, how many other civilizations might exist out in space? You've got a bunch of different variables in this equation, and you tweak just one of them and it completely throws off your answer. So, like, if we're trying to estimate how many dinosaur species existed during the Mesozoic, well, how quickly are they speciated? What's the average lifespan for a species before it either evolves into something else or goes extinct? And at what point do you call it a different species? If it's one lineage evolving over time, then over 10 million years, is it one species? Or is it 10 species? Or is it 100 species? If it's just one lineage evolving over time? And like, there's a ton of variables. But as for dinosaurs that have been discovered and not named, there's probably... I'd say there's probably at least 500 different dinosaurs that have been discovered but haven't been named yet. And maybe some of them shouldn't be named because they're not based on very good material. It's just a few scraps here and there. But I know of at least 24 different... Well, I personally know of at least 24 different dinosaurs that have been discovered and are just currently being worked on. And I would love to be able to tell you about some of those now. But this is stuff that's, it's not my place to announce this. I'm not in charge of these projects. Yeah. But just to tantalize you a little bit, a colleague of mine is on a team working on a new dinosaur from Antarctica, which should hopefully have a very fun name. Can't tell you what it is. I have some colleagues working on some new dinosaurs from Montana, and from Wyoming, and from New Mexico. Some new dinosaurs from China and Mongolia, some new dinosaurs from Argentina. Yeah. Exciting things are on the horizon. Yeah. Anyhow. How many simply can't be named because they're too fragmentary? It depends on who you ask. Some people are really willing to name a new dinosaur based on just fragments. So, yeah. There's a dinosaur who's been named Thanos. That's the genus name. Not making that up. Thanos. It is based on a single vertebra. I probably wouldn't have named a new dinosaur based on a single cervical vert like that. But, you know, this team did. And I happen to know one of the authors, actually. I've worked with him in the field. Nice guy. Hopefully they find more of it, and hopefully it turns out to be legit. But, yeah. You can tell by the shape of that one bone that this is an Alvarezsaur. So these guys have very distinctive vertebrae. We know it's a member of this group. So it's from the same group as, say, Alvarezsaurus, right here, who is pretty well known. And Carnotaurus is also an Abelisaur. It's a member of this same family. Good old Carnotaurus. Yeah, So we have a good sense for like what the general body shape would be for this animal. Probably similar to this, but did it have horns like Carnotaurus? We don't know. We've got a single vertebra from this animal. So, yeah. Some people are totally content naming a new dinosaur based on a single bone. And some of us demand a bit more than that to be able to name a critter. Oh, yeah. Hope that makes sense. Rushbring says, I didn't realize it was so little. It's not a big animal. Yeah. Which, again, you know what I'm going to ask, chat, when I see this? What am I going to ask? What's my first question when I see, oh, it's awful small. It's a new species? It's got small arms, top track. Every member of this family has small arms. Yeah, Charlie's Dragon has got it. Is this thing full grown? Is it a juvenile? What's going on ontogenetically? What growth stage is this animal at? Does it look different and new just because it's small and the juveniles look different from the adults? That's what I want to know, and that brings us back to this paper. Accounting for intra- and interspecific variation. Dinosaur growth models can underfit observed variation by excluding key factors. Ontogeny-only bias may appear in the analysis and presentation of data itself. Recent work shows growth models can contradict evidence of interspecific variation. And sexual variation is an underappreciated form of dinosaur intraspecific variation. I do wonder about that because, again, we don't have any strong evidence of dinosaur sexual dimorphism. Males and females being different. In a skeletal sense, we don't have strong evidence of that. So yeah. In histology, asked Wombat Hole, it's going to be real tricky to do histology on a vertebra, especially a small vertebra, especially when that is the only piece that you have of this animal. I don't think that museum that houses this is going to let you cut that thing open and look at the growth rings inside. I don't think so. Generally, for histology, if you want to count the growth rings, you got to look at a limb bone. You don't have to look at a limb bone, but those are usually your best bet, especially a tibia. For whatever reason, the tib seems to be the best bone, with the least amount of remodeling over the animal's lifetime. So you'll have nice, clean growth lines in there that haven't been all messed up. Other bones tend to get messed up. The growth lines get smudged, essentially, but in the tibia, they seem to be the clearest. So, yeah. Anyhow. And Kennedy, yeah. We only know of females, and even some of those, like... medullary bone has been reported in dinosaurs. The bone that female birds lay down, that layer of bone that shows that they're gravid. They're like drawing calcium from that to make the eggshells. That's been reported in dinosaurs numerous times, but not every paleontologist is convinced that that's a real thing, that that's what we're actually seeing. My undergrad advisor, Dave Verricchio, he's not convinced that medullary bone is actually a good indicator of... He doesn't think it really is medullary bone, necessarily. I like how the title here got cut off. The YouTube titles have to be shorter than Twitch titles. Troodon, talking about chat's favorite dinosaur with special guest appearance by Troodon? What? No, it's special guest appearance by Troodon expert Dave Verricchio. So could it be that medullary bone is
Tradoon.
Special
Tradoon.
that birds have?
Tradoon.
Just about everything about birds today is optimized for flight. They went through this evolutionary bottleneck. Here, let me go back a little bit.
that if you see a clutch of eggs and you see an adult on top of them, our first gut reaction, they were just naming it nicknames. I know there's no science to that, but the gut reaction is to call Big Mama, and we kind of like go, oh yeah, that makes sense. But if you really step back and look at vertebrates in a bigger picture, there's lots of male care in fish. Have lots of male care, paternal care. And if you think about like where dinosaurs fall, birds have biparental care. There's one group, rat tights have a lot of paternal care, male care. Lizards may have no care. Crocodilians mostly have maternal care. So they're kind of in this spot where those 4 different strategies are about equally likely, right? There's no favoring maternal care versus paternal care versus biparental care versus no care. If you had to just guess from their phylogenetic position, it could be any of those. So that's kind of the starting point. And you have to kind of like get rid of our mom bias as mammals.
So I actually talked about this the other day on Blue Sky, on Mother's Day.
Here's something stranger than science fiction. Prehistoric fact.
Naps with Cat, thank you for the follow. Welcome, welcome. Good to have you here. Yeah, Mother's Day. Happy Mother's Day. All the wire mothers out there. There we go, yeah. So this person posted, Happy Mother's Day to this oviraptor mama who died protecting her clutch of eggs from a falling sand dune back in the late Cretaceous. Yeah. And I said, even though this specimen's nickname is Big Mama Oviraptor, it's likely it's actually a male Oviraptorosaur on the nest, and it's actually genus Cydipatia, not Oviraptor. Especially if the male's brooding the nest thing we see in modern rat tights reflects the ancestral condition in birds. If there's anything mothers really love, it's unsolicited corrections to possible minor factual errors. Anyhow. But yeah. Oh boy. And Bad Fraginator says, has there been any notable exodus of paleontologists from the U.S. with government cuts to scientific research? It seems like that probably will happen soon, Bad Fraginator. Paleontology tends to be pretty underfunded in general. So we're kind of used to not having any money to start with, but it definitely is affecting new students joining up in laboratories for PhD programs and stuff like that. Some of the folks that I know at Berkeley are really struggling to make ends meet, and they might not be able to take students next year or the year after that, and it is a disaster. So, yeah. Yeah. Anyhow. And addicted to capping, any truth when Dr. Grant says dinosaurs can change sex in a single-sex environment? So that's supposed to be because of genetic engineering in Jurassic Park. It's supposed to be because of frog DNA. That's a plot point. It's not that the dinosaurs could do that to start with, like back in the Mesozoic. And dinosaurs, we think, had chromosomal sex determination. So they actually did have sex chromosomes, just like modern birds. That's where birds got it from. But unlike in mammals, where it's often like XY sex chromosomes, it's ZW in birds. Yeah. ZZ or ZW. ZW leads to females, ZZ is males. So unlike in mammals, I think most, if not all mammals, generally speaking, I think there's always exceptions with individuals. Life is a rich tapestry and all that. But with males, generally it's XY, and females are XX. In birds, it's flipped. Not only the different letters, but the ZZ, the 2 matching sex chromosomes, is for males in birds. And ZW is for females. They don't match. So yeah. interesting stuff. So since birds have that, and birds evolved from dinosaurs, it stands to reason that birds got that from their dinosaur ancestors. But is that true for all dinosaurs? Dinosaurs were a really diverse group. Lots of different body shapes and sizes, ecologies, and everything else. So maybe, I don't know, maybe it's not true for ornithischian dinosaurs. Maybe some of them evolved different things. Crocs have, I think, temperature-dependent sex determination, right? And if we're looking at our EPB, our extant phylogenetic bracket, if there's something that's unknown for Mesozoic dinosaurs, we look at their closest living relatives for clues. We look at birds, who are living dinosaurs, and we look at crocs, who are kind of like cousins to the dinosaurs. Let's look at crocs. The sex of the developing, incubating young in the eggs is temperature dependent. Constant nest temperatures above 90 degrees Fahrenheit, 32 Celsius, produce more males, while those below 88 degrees Fahrenheit, 31 Celsius, produce more females. Which is funny, because that's the opposite for sea turtles. With sea turtles, they have temperature-dependent sex determination too, but higher temperatures mean more females, lower temperatures mean more males. Hot chicks and cool dudes is the phrase that we often use for them. But yeah. Are people at chat not familiar with that? We'll be talking about this a lot on, when I'm in Florida next week, and on Friday when we interview Dr. Justin Peralt. But, yeah. Let's see here.
So it's been known that temperature affects the sex of sea turtles for quite a while, about 40 years now. So what we want to look at is whether there's a difference in the switch point that produces male and female offspring between populations. We looked at this in flatback turtles and green sea turtles, and we looked at these across the northwest of Australia. So our research found that there's quite a difference in the switch point between male producing and female producing temperatures in sea turtle populations, particularly in flatback turtles. And this means that at different temperatures you get different numbers of males and females between these different populations. So this research was done in collaboration with the West Australian Marine Science Institution as part of the Kimberley Node projects. We also worked alongside the Department of Biodiversity, Conservation and Attractions, and worked with a whole range of Indigenous ranger groups up in the northwest, particularly
I don't think we know. Again, it's only been known about for about 3 or 4 decades, maybe close to 5 now, that sea turtles have this sex-dependent, temperature-dependent sex determination. TSD? Here. And it has large, important implications for their conservation. No, Charlie's trying, I had that backwards.
So traditionally, most of what we know about sea turtles come from the nesting beaches. That's where we have easy access to the animals. Females come up on these tropical beaches and lay their eggs in warm sand, and the female green sea turtle, for example, will lay about 100 ping pong ball size eggs, and she may lay 2 to 8 nests within a season. However, the number of nesting females on a nesting beach is not always a good measurement of the overall health of a population.
right.
Today, conditions on nesting beaches are changing, and we're seeing a general trend of warming now. One of the really interesting things about sea turtle is that the sex is determined by the incubation temperatures of the eggs, with cooler temperatures producing more males and warmer temperatures producing more females, with only a few degrees can really alter the sex ratios of turtles' hatchlings.
We don't know a lot about sea turtle sex ratios, so it's really important to get that data to help us determine the abundance of the population, the sex ratio, the survivorship of different sexes. But figuring out the sex of sea turtles is not easy.
One of the big challenges that we have is that there's no physical characteristics that can be used to determine the sex of a sea turtle until it reaches sexual maturity, which is when the males develop a longer tail than the females.
Yep.
Most studies rely on measuring the temperature of nests.
So that's kind of a funny thing. We talked about this a little bit yesterday. When you see a picture of a sea turtle, so like Nemo sea turtle. Here's Crush the sea turtle, right? Oh, this might actually this might be wrong in the sense, well, I don't know, how long is that tail? Males have much longer tails than females, and so when people see like a male sea turtle, they're like, what? What is that? Because the tails are like stupid long. And we're not used to seeing that because most of the time when you see portrayals of sea turtles in popular media, in ceramic models, in illustrations, you almost always see a female because those are the ones who come up on the beaches. The males have a much longer tail. And people look at it and they go, it doesn't look right. What? 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 Yeah. There we go. So almost any time that you see like here. Ceramic sea turtle. They're always like hatchlings or they're females. You never see one with a long tail because it just, people don't think it looks right because what they're used to seeing is this. To have a long tail trailing behind it would just seem, no, we're not used to seeing that.
Dinosaurs were the sort of creatures you might think of as inhabiting another planet.
Red Zed.
Or the kind you dream of in a bad nightmare.
Thank you for the 32
Counting
months
the
of
days till they drop another Spinosaurus.
Hopefully it won't be too long, Red Zed. You know about Spinosaurus mirabilis, right? The one that was just published recently. Anyhow, here's a male... Oh. There we go. Here's a male leatherback turtle named Ricky. And look how long his tail is. Much longer than that on a female, you know? Compare that to this. You know? Much shorter tail on... This is clearly supposed to be a female leatherback. There's the tail right there. Anyway.
Estimate the sex ratio.
So you can't really tell if a hatchling is male or female because they don't develop that long or short tail until they're already several years old, you know?
Most studies rely on measuring the temperature of nests to estimate the sex ratios that would have been produced given those temperatures. Another approach is to look at the sex ratios of sea turtles at a foraging ground.
The foraging grounds give us a unique opportunity to look at the overall population because it's many.
Again, when we're talking about things like sex chromosomes and stuff, and like, you know, how sex is determined in different organisms, I should give you a link to a whole stream that I did about this back in October. Let's see. special stream about this back in October. There's also a fundraiser for an organization called Queer Care. But talked all about the interesting range of like where is this? It would have been October, right? It's before this, it's before that, before I went to SVP, but after I was in Utah, right? What the heck is that far? Anyway, I talked all about biology.
But on the land, the greatest of all the reptiles, the dinosaur, was king.
Thank you for the 40 months of support. Thank you for that prime there, InGen.
Paleo side
Excellent.
shake, paleo salute,
Thanks for
paleo
keeping me
chop.
here online. Yeah. There we go. Yeah, here it is. As somebody who works in the field, there we go. Stream for Queer Care, which is a really cool organization. I'll talk about that in a minute, but there's a couple more things I've got to sort out. Nothing technically was working this morning. I've had to restart my computer 3 different times. It's wanted to update 3 different times. I don't know what's going on with Microsoft, but there we go. Microsoft. There's a wonderful quote from an evolutionary biologist by the name of J.B.S. Haldane. Yeah. And I think it, in almost a cheeky way, it applies to our topic for today. He once wrote, "The universe is not only queerer than we suppose, but queerer than we can suppose." In this sense, queer is meant to be, the meaning that he's implying there is strange, complex, interesting, unexpected. But it also applies to, I guess, queer in the queer care sense. So we're going to be talking about all kinds of different critters today that defy expectations. They don't fit into these neat, tidy little kind of wrapped up in packaged gender boxes that we as humans often stray toward. Nature. Yeah, so like Puggo Wuggo says, biology is so fascinating, way more complex than what high school teaches you. 1,000,000% yes. Whether it's Komodo dragons, who can actually reproduce without the involvement of a male. Females can give virgin birth. Whether it's birds who are born half male, half female when something interesting happens with their sex chromosomes. Whether it's California sheephead wrasse, these really cool fishes who are all born female, and only the most successful females who are well fed enough and become dominant enough, only they transition to becoming males over the course of their lifetime. None of them are born male. They're all born female, and only the biggest, baddest females, I almost said a different word there, transition to becoming males. Fascinating stuff. Like, nature is full of really weird, interesting examples like this. So if anybody tries to tell you, oh, you know, well, biology says that there's males and females, and those people don't know anything about biology. Like, try talking to a biologist. You'll learn that nature is far more complex, fascinating than that, you know? So yeah. Anyhow. Where were we? Oh yeah, we were talking about sea turtle sex determination.
10 years of different turtles being born on different nesting beaches, which come to these foraging grounds. So you have immature turtles, which can be anywhere from 2 to 20 years old, and then you have mature turtles, which are generally 25 to up to 50 years old.
So this work is done in strong collaboration with the Australian government, the Queensland Parks and Wildlife, and the foraging ground that we studied is called the Howard Group. It sits in the northern part of the Great Barrier Reef, and from previous research we've done, we know that 90% of the turtles originate from the 2 Great Barrier Reef populations, with roughly a 50-50% split. So a typical day in the field, we catch somewhere between 70 to 100 green turtles in a day. After the turtle is caught, we take it back to the boat.
I've pointed this out before. How cool is that? You're like, yeah, I gotta go dive after a turtle.
So a typical day in the field.
That's some dedication right there. Watch this. Imagine this is your job. Where you're like, yep, there's a turtle. Hang on a sec. I gotta go grab those.
Oh man! Turtles in a day. After the turtle is caught, we take it back to the boat. We measure and tag it. We also take a blood sample that we use to find out whether it's male or female. And then we take a small tissue sample that we use for genetics to find out which nesting population these turtles belong to. What's quite unique about what we're doing is that once we apply the genetics and we can estimate the nesting origin of these turtles, we can actually calculate nesting population-specific sex ratios for different size classes.
That's true.
So one of the surprising things that we found in this study was that the overall sex ratios at the foraging ground wasn't that alarming. It was slightly female biased. But it wasn't until we applied the genetics that we saw that the turtles coming from the cooler southern nesting beaches were only moderately female biased, with about 65% female.
Okay.
However, the turtles coming from the warmer northern nesting beaches, we found this extreme female bias of 99% or more females in the young turtles.
So, yeah, that's potentially a problem. I mean, if given a choice between having 99% females or 99% males, of course you want to have 99% females, because at least you'll get some offspring. But still, that's a big problem, you know? And maybe there's something that can be done to help. Maybe collecting those eggs and then incubating them in the lab under lower temperatures, you could yield more females and then release them. But these are the things that require a lot of human intervention. And that's not ideal when you're doing conservation work. You don't want to have to be constantly intervening all the time in order to keep a species from going extinct. You want them to be able to survive and thrive on their own. This isn't like, you don't want to have to stock the ocean with sea turtles in the same way that you stock a lake with fish because people decided to build a dam there or whatever. Like, tear down the dam and let the fish swim up and, you know what I mean?
Which means that virtually no male turtles were born from these nesting beaches.
So this information was unknown until now. Nobody's combined these techniques before to figure this out. And most sea turtles reach sexual maturity around 25 years old. And the immature turtles that we examined for this study are probably at least 5 years old. So we're thinking that we'll start to see this feminization of the populations coming into full effect in about 20 years from now.
Which means that you could have a total population crash. If 99% of the turtles in that population are female in a given area, you could have like tons and tons of females going up to nest, and then all those eggs are not fertilized. You know? Their population could fall off a cliff, and it could just, happen over a couple years or something,
However, a few male turtles really goes a long way. Because male turtles are polygynous, which means that they can mate with several females. It's important to remember that they've been around for 100 million years. They've outlasted the dinosaurs, and they've adapted to a changing climate through that whole time. However, the climate is changing faster now than it has ever. And so the questions that we're all asking is, will it be able to adapt? And
so that's the thing, is that Earth has gone through tremendous climate changes in the past, but it's always, I think without a single exception, maybe there's one exception. It's always happened slower than it's happening right now. The one exception to that might be the end Cretaceous extinction event, when a gigantic asteroid hit our planet. Bam! Climate change just near instant. And then it blocked out the sun, and you know the story. That might be the only time in the entire history of the Earth when the climate has changed faster than it's changing now. Even in every other mass extinction event that's occurred on our planet that's happened because of climate change, that was still more gradual than what we as human beings are doing to our planet right now by warming the atmosphere, you know? So yeah. So sea turtles have adapted to a changing climate before, but it's always happened a lot more slowly than it's happening currently. Something to keep in mind.
Climate through that whole time. However, the climate is changing faster now than it has ever. And so the questions that we're all asking is, will it be able to adapt, and will it be able to adapt fast enough? And I certainly hope so.
There's a link to this video from NOAA Fisheries. Genetic engineering options. I mean, genetic engineering is one of those things that's still kind of in its infancy in a lot of ways, and unfortunately, with sea turtles, they are very, very low on the priority list in terms of genetic engineering. Let's take for granted just for a second that that's a good idea. Let's just assume that it is, for the sake of argument. There's so many other priorities that are going to take precedent over sea turtles. Yeah. Anyhow, we'll be talking more about marine turtles on Friday of this week during a special bonus Friday stream, where I'll be interviewing Dr. Justin Peralt about his work with leatherbacks and other marine turtles in Florida. I'm going to interview him over Zoom on Friday. We might start the stream a little bit late that day, given that I think it'll be 6 p.m. or so when I start the interview with him. Tune in for that, and then I'll be, just a few days after that, I'll be out in Florida doing fieldwork with them. Take a look at this.
Yeah, so here we've got a leatherback hatchling and then a loggerhead hatchling. When we're driving up and down the beach, what we're looking for are those crawls that you see in the sand that move from east to west. So the animal is leaving the ocean and then crawling west towards the dune. And based on those crawls, we can kind of see what type of animal, what species of animal is up. And then what we're also doing is we're waiting for that animal to start laying her eggs before we touch her or study her, examine her in any way. As during that egg laying process, what happens is those fight or flight hormones that might tell that turtle normally, there's a big scary human predator near me, I need to go. Those hormones are significantly reduced while they're nesting, and so they're not typically responsive to external stimuli during the process when the eggs are physically coming out of the body. And so that's when we have that 8 to 12 minute window to do the majority of our work, and that's when we typically work those animals up to disturb them the least. So we'll give these guys kind of a second chance because they wouldn't have made it out of the nest on their own. Turtles and humans are not really that unique. We all eat the same things. We like to enjoy the same habitats. And so if you're seeing unhealthy animals that are a good indicator of the health of the ocean, that's just in general a good indication of the health of that ecosystem and the food that's within it. And so I think it's important for people to realize that while we do see a lot of nesting, and that is a very positive story, there's still a lot to be done. And I think just people realizing that we all overlap on this planet, and if the turtle is unhealthy, the human is likely to be unhealthy too. And I think that's important for people to remember as we're all connected.
Yep. Good stuff. So we'll be interviewing Justin, having a conversation about marine turtles, especially leatherbacks, on Friday, and I can't wait. It's going to be great. Anyway, with that said, I still need to send a message to Shark Geek about it'd be cool to do a collab when I'm there in Florida next week. So that and some other messages I need to send. Let's wrap up today's stream. We've been going for 5 hours. Let's wrap this up. And here's a Deinonychus skull to put under our credits, as we were talking about Deinonychus earlier. There we go.
The incredible water monster, Elasmosaurus.
And thank you, Leafhopper, for the follow. Welcome, welcome. Good to have you here. Sneaking that in right under the wire. Rhacodactylus is streaming right now. Rhacodactylus is, like me, a scientist who streams here on Twitch. He's a cognitive scientist. He studies people's beliefs. Why do people believe weird things? Whether it's urban legends, internet rumors, conspiracy theories, anti-science, whatever. In order to be able to combat harmful misinformation, first we have to understand it and why people go for that kind of thing. That's what he's all about. So we're going to go right into him. It's pretty cool. Thank you to everybody showing up in our credits right now, from new followers and raiders. Thanks for coming in and enjoying science with us. Thank you to the people who make these streams possible by contributing financially. The subscribers, especially recurring subscribers, and the gifters and the cheerers. I couldn't do this without you, let alone full-time. Holy cow, it is a dream come true to be able to make my living doing science outreach full-time, and it's only because of you supporters that that's possible, so thank you. And likewise to the moderators, mods. You are the beating heart of this community, and I and everyone else here are deeply grateful for your commitment and your patience and your hard work and showing up. I appreciate it tremendously, mods. With that said, oh man, if we get 4 more people who click the Let's Go raid button, we can bring it up to 200 to raid into Rhacodactylus. Anyway, let's go right in. I'll see you there, and I'll see you tomorrow for some more paleontologizing. Everybody, take care. I'll see you soon.